Claro, claro.
You should not overlap.
Yeah.
Okay.
O sea, los que ya se le instalaron y está bien, no hagan nada. Los que no han recibido la contraseña, eso, ellos sí hacen lo que ahorita.
Pero hicimos el download, pero no tenemos el activation code.
Así es, claro. Los que no tienen el activation code.
Yeah, we have it here, but we can't have the activation code.
Sí,
So
pero,
when you download 30-day trial version,
I have, yeah, I have.
have they given you activation code?
No, never
No.
received it.
But okay. So can you operate Design Builder right now? It's okay, don't worry. Okay. 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 Just open one file. Okay.
ahora la consigo.
Must have at least one license.
Okay.
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 Now, the file he is giving you. Yeah. Go license.
License? Yeah.
License file. Okay. Next. And you have to spot that file which is giving you.
¿Te lo envío a tu Gmail o a tu PUC?
Este pesadito no puede
A Gmail. Jiménez Cecilia 36.
Okay. So I have to go somewhere.
Ya.
So I give him oh. No, but he just
Yeah. So that file is sending, you store somewhere, and you locate that file.
okay.
Once you have that file, put it on desktop, locate that and double click. Yeah? I'll show you the example.
Okay, thank you.
Are you okay? Sir.
Oh, lo tengo para el
No, perdón. So we're waiting for you in the wall, right?
No, it's fine.
Aquí está Claudia, ¿no?
Ahora la busco.
Martin,
Yes?
shall I start?
Yes.
Okay, welcome. I'm Rajan Raval and I'll be boring you for next 3 hours and then tomorrow also, if you come back. There are a couple of things which I would like to understand, but before I do that, some of you would have downloaded the trial version. If you have not received an activation code with it, then you use a license file. Martin has shared the license file with you. If you have installed it, don't do anything, but if you have not installed it, just follow what I am showing you here. Okay? When you double click on Design Builder, it will show you something like this. Just go to a help file, help drop down here, and a second one where you say license. When you go to license, you will further see one more license tab. You go here, license. Okay? You have 3 options: activation code, license file, and site network license. And I'll explain you what this is for your future reference. But for a while, you select on license file, say next, and you will see something like this. On right hand side of this blank one, you will see 3 dots here. Click at the 3 dots and it will go to a place where you should have your license file. So the email which Martin has shared with you has a file star.lic, something like that. Okay? You click that file. I'm not doing it because it's licensed. You click here, say OK, and you will be able to run the Design Builder. Okay, so let's do this first. And if anyone has any challenge, let me know.
Si alguien no ha podido instalar, o sea, no le está funcionando el business builder porque no le llegó la clave, me avisa. ¿Ya? Nunca te llegó.
Once you do that, if you want to check whether things are happening properly or not, what you can do is that you can go again to help, go to license, and you should be able to see some green dots here. Thanks. The green dots which you see on my screen and green dots which you see on your screen will be different. Okay? But at least you should be able to see Energy Plus, visualization, and Add to Act, if I'm not mistaken. You might not be able to see CFD, daylighting, costing, optimization, because the license which is given to you, it's primarily for building envelope design and HVAC design, not for computational fluid dynamics or something else. Okay, so that's a module which has been given to you. All of you are okay? Yeah? Okay. So now I have a question for you. Since this is a workshop, not like one-way teaching, I would like to go with your preference. What do you want to extract out of me and my colleagues in this 3 hours and tomorrow, whatever time we have? So, that two options you have. One is that I start telling you something about simulation, what is required, what you should do, what you should not do. What you should do you will learn, but what you should not do is very important. And then we start a little bit with our exercise on hand, right? So that is one way to start. Second way is that we start with what is simulation. Then I tell you what all capabilities simulation has, what all you can do, then do's and don'ts, and then exercise. Whichever way you want to go forward, I am fine. Probably third could be we don't want to do anything, we just want to start with the exercise, that's also fine. So, can I have some response from the group? Yes?
Maybe the exercise, in like it's like a small version probably, to make questions emerge, probably.
Okay.
So that the theory that you give is much more concrete, probably.
Okay. Okay. Anybody else? Okay, so what he's saying is that we start a very small exercise, but then we don't go too much into the detail. Straight away we try to understand a little bit of theory, what he's saying, so that you get a little bit more about what am I saying whether it makes sense or not. Is that okay? Right? Okay, so let's do this way. You have for that everybody needs to be on the same platform. So you have the design builder installed with you. Who has not been able to install? All of you.
I finished installing.
Sorry?
I continue installing with the license. I need 5 minutes
Okay.
to finish installing.
Oh, don't worry. Tomorrow I'm going to come back. You can stay overnight here. Okay, so let's do exercise right away. Okay? What we will do, let's make one small floor plate. Okay? Which would be probably about let's say 10 meter by 20 meter. Do you use SI or IP? Units you use SI or IP? Okay, thanks. So 10 meter by 20 meter, some block which we are going to make. To start with, we call it a making of a geometry. Okay, so let's do that first. And what I'll do is, I will do, if you want to do it with me, you can do that, or if you want to do after I finish how to do it, you can do that as well. Sometimes it becomes difficult for somebody to do it simultaneously. Okay, I can do twice as well if you want. One on my own, second with you. Okay, so let's see how it works. You will have something like this on your screen. Go to File, left hand side top, say New File or Control N. You will see a pop-up screen which says Title, Untitled. Right now we can say PUCP Test 1 or whatever name you want to give, it's okay. You might see London instead of Ahmedabad here. Okay, whatever it is, don't worry, just keep it. We will see how to change it later on. And just say okay. Just put a title and say okay. The new file will open up. Might take a while depending upon how much RAM do you have and what is the processing power you have. Now, unlike other softwares where generally you see something happening on left side, something happening on top, something happening on right. That's what the general software screen looks like, right? Design Builder has all four sides, something is happening. So something is happening here, something is happening here, you need to concentrate here, and something also will happen here once we start making a building. What you're seeing right now is XYZ axis. That means the canvas is blank, there is no building there. But there is a PUCP test 1 is a building name appears here. Nothing appears beyond this. The moment we make a building, something will appear here. Okay? At the same time, what you're seeing here in a axonometric view. I hope everybody understands what is axonometric view, right? So the third dimension, 45, 45. Because we want to draw something a little bit more precise, 20 meter by 10 meter or 10 by 20, probably it makes sense for us to get onto the plan projection instead of axonometric. So what you do is just go right at the top, drop down and say plan. Okay? You see layout, location, region. This is where we are going to draw a building which would be north aligned. If your building is not north aligned, don't worry, just draw it box building right away. Now when we are drawing this, what will happen is that building also will have certain character which will appear here. In simulation, any building which we are making is going to be a thermal zone. Thermal zone means anything which is going to happen inside, all thermal transaction would be calculated. Whether it is through the wall, it is through floor, it is through roof, or even through the computer and people are sitting here. Although for us as an architect engineer it is a building, but for software it is a one thermal zone. Okay, so what we are going to do, we are going to make a one thermal zone like this. To do that, there is a terminology which we use is to add a new building block which appears here. Okay, when you start your file, probably only once this will appear. Once building gets added, this may not appear again until you open a new file. Okay, now when you click that, we will go to the canvas to draw, but don't draw until I show you how to draw. Okay, so what I'm doing is I'm narrating. You may not do anything, just watch. I will delete that stuff and we will do it again. Okay, so I'm adding a new building block by clicking at that hut and plus sign. Again something appears. I'm not bothered about anything right now. I'll say okay. A new project will get set up within the file. So that means that one file can have multiple projects within that, one building and sort of second zone and third zone and fourth zone. So what it is doing right now, it is just setting up the first zone. Okay. Now the moment I added something, although nothing is being seen here, but things have appeared here right away. A building 1, and some more stuff has appeared here, some more stuff has appeared here. When you are going to draw, you will get some kind of guidelines. How are you going to draw here? All help related work appears here. So instead of going for F1 and trying to find what is happening, immediately what is a building block, how to draw it, and what is the characteristic of does appear here. Okay, so that's how the pane works. Now I need to draw something here, but before I draw, I need to state that that drawing or that block is going to be building block, and hence I need to make sure that on the left hand side where my cursor is, let's say block type building, there are two other kind of blocks also can be inserted, but what is that we will see some other point in time. Right now you need to make sure that it is a building block. It is an extruded block. That means if I draw in a plan, it will get extruded on its own. The extrusion would be of 3.5 meter on its own. If you want to change, you can change, but we are not going to change it. Okay? And that block will be completed on its own. So auto-complete block. Now there are two ways of doing it. You don't need to do it. We'll do it again. One is that I simply draw it like this. I complete the block. What you see here is block. Okay? Let's not do that. What is going to happen now? Again, because I have already added a building, that hut and plus is not going to appear. I need to add a block already on this canvas. For that, I'll again go to plan and I'll use this called add block. The moment I say add block, again same thing will appear on the left hand side. Now this time, instead of going with some kind of line, what I'll do, I'll go here and I'll say rectangle. Okay? Now just concentrate little bit, because this is what it is crucial. Now the moment I click here, you see the block is getting made. It's not a polygon. I'm not drawing 1, 2, 3, 4 vertices, but at the same time, rectangle block is appearing. And you don't see anything here for a while. Okay? How do you make 20 meter by 10 meter is a question. You need to enter somewhere some number, right? And that is not appearing here. But the moment you say on your keyboard 20, immediately something will appear here. Okay? So 20, comma 10, here is my block. Shall we do it together? Yeah? Yes or no?
Yes.
Okay. If you say C, I will understand. So I'm undoing this part. You have something like this, but you will have that hut and plus. So add a building. I'm adding a block. Before doing that, I'm just going to the plan. I'm adding a block. I'm making sure it is a building block. I'm making sure it's an extruded block. I'm making sure it's a 3.5 meter height and autocomplete. You will have a polygon. Instead of that polygon, you can say rectangle. Go to number 2. Hit the cursor on the canvas. Draw. Now type 20. Immediately length will appear. Comma. Space 10. Sorry. Then you go on the globe icon here and make it 3-dimensional. Yes? In one of my sessions, what we did is we made a back wall as a mirror wall so that I can see everybody's screen there. Did you get this up to this point?
Yes.
Perfect. Now, while you got this, are you okay?
The separator between X and Y is a space, right?
Yes. Even if you don't have space, it's okay. I think it's okay. Are you okay? You're done?
No, I didn't get it. I got lost in the title of the number.
What did you type? Something?
20, 20,
Comma. Space. See, what has happened is that building got a block on its own. And that also got something called zone. Now, this is actually a thermal zone. Right? If you go and say plus, you will see few more things. What are you seeing? You're seeing ground, you're seeing roof, you're seeing wall on 4 sides. So what is the area of that wall? And so it's so forth. Now it further has some more information. You say that it is an external wall and it also has a window of some area. So this is how you can sometimes figure it out, what is the area of the window, what is the area of the wall, and so on and so forth. Okay? Any questions so far? No. Um, Now let me give you a little bit more idea about how this whole thing is working. What we are doing right now is that we are simply generating a model. And there is a difference between model and a simulation. And I'll explain you what is that. Model is something which is having all kind of characteristics. The model could be this, and model could be equation. Model could be statue or as well. The moment you try to look at various scenarios, what you're doing is you're simulating that model in a various environment. I can put this model in a Lima and I can put this model in a San Francisco and I can see how things are changing. But model remains same, simulation changes. Or the walls of this can be of X U value or a Y U value, and I can simulate it to understand what is the difference between two scenarios. Model can remain same. So it's very important to understand or rather distinguish between model or modeling and a simulation. Okay, it's not the same thing. When you want to understand any kind of energy consumption, whether it's electricity or even a thermal transfer of wall characteristics or roof, the multiple thing also happens in the building, and that is being shown here as activity, construction, opening, lighting, HVAC, generation, that is for solar photovoltaic, something else, and CFD. What we will be trying to do, and again I am saying trying to do today and tomorrow, is at least 1, 2, 3. At least building level decisions and how to model it building correctly, we will try to attempt it. But what is more important is to understand the functionality of design builder. The moment you understand how to make a geometry and how to make, we call it a templates, activity template, construction template, opening template, the moment you know how to make template and how to simulate it, things will become very easy. And that is what my effort is going to be for whatever hours we have. Okay. Now, having said this, if you permit me to show you some basics of simulation, probably I would like to switch gears a little bit and then say, let's try to understand a little bit of theory and then come back on this again. Before you go home, at least I would like to take you to a level that once you go home, you don't feel like sleeping and say, let me do something more on design builder before leaving tomorrow. Right? So we will try to do something up to that level, and then whenever you feel comfortable, we'll sort of break for a day. Is that okay? Design builder is one of the, we call it a graphical user interface. Okay? Graphical user interface of a calculation engine which is called Energy Plus. Hence, you see a logo here of heart of a design builder called Energy Plus. Now, what is Energy Plus and what is the graphical user interface? Energy Plus is a, I won't say software, but a group of equations. And when I say group of equation, it could be like 800, 900, 1000 equations put together for various kind of calculation. One equation will do calculation for wall, heat transfer, another will do for window heat transfer, third one will do for indoor solar gains, fourth one will do calculation for window lighting transfer, and so on and so forth. All those comes together and makes a calculation engine. Now, if somebody needs to work on a calculation engine, and I know probably he has worked on another engine called ESPR, it's very, very difficult. I simply will show you how difficult that is. And since it is too difficult to work directly on that engine, one company has developed a graphical user interface easy for us to work on a geometry, on a templates, and so on and so forth. Okay? So whenever you use Design Builder, please keep one thing in mind, that there is something else working behind the Design Builder. And there is always a possibility of doing very detailed modeling coming out from Design Builder and start working on Energy Plus. Okay, so this is a relation between Design Builder and Energy Plus. Energy Plus is a free engine developed by US Department of Energy. Every 6 months it's getting updated, new and new algorithms are getting added to it. Hence it is one of the most popular and used software engine for building energy simulation. On top of Energy Plus, there are few other people who have developed a graphical user interface, and one of the most used is a Design Builder. Design Builder needs to be purchased. Energy Plus is freely available. Anybody can use it. Okay, but it's difficult to use. Just to give you a little bit of understanding how does Energy Plus look like, I just opened something called Energy Plus here. So don't look at the behind. This is how Energy Plus looks like. Okay, you don't see any building anywhere. You don't see any kind of graphical user interface. What you see, a number of tabs here, some kind of editing, text editing feature here, and so on and so forth. I'm not sure whether my text editing is going to work, but let me see. Yeah, okay. But the way it works is, sorry. The way we have added a building very easily in a Design Builder, in Energy Plus you need to add everything manually. So for example, I need to consider this as a 0, 0, 0 coordinate. Okay. Then if I say this is 20, 0, 0, then I will say 20, 0, 3.5, and so on and so forth. What I would be making is a one wall like that. By entering 4 times, you need to enter some values, you are making one wall. Okay, now in that, if you have 3 windows, again you need to calculate what are the coordinates for this and enter that. And you say now subtract out of it. Same way here, same way other side, same way that side. Now you know how difficult that is. Okay, just to avoid all that, we use something like graphical user interface. Like this. Okay? Any questions so far? Okay. So now let me go and try to give you a little bit of understanding about simulation engine, simulation subject itself. I'm here primarily for a project which is collaboration between University of London, University College London, Martin's team and few other team members in Lima. The project is called Grounded Energy Model for something. and as a part of that, I am here, and hence I'm happy that I'm delivering. So that's about, and GemDev has a website, gemdev.org or .net, something like that. You'll be able to get some more. All of us have done simulation. When somebody was playing with a car, when somebody was playing, what we were doing is we were simulating certain kind of scenarios in our mind. We were believing that I'm a taxi driver or I have a car and I'm playing that. All that was simulation, right? The moment you add a certain kind of quantification in it, these games were simulation, or we were playing earlier, right? This is also a simulation, but other than some kind of quantification, whether you got 5 points or 10 points, or you earned X amount of money or you lost X amount of money, you also strategize something before you start doing some kind of work. That is also a simulation. And in a building energy modeling, it's very, very important that you strategize before you make a model. I'm not saying simulation. Before you make a model, it's very, very important that you strategize how to do it. Why do you need to do it? Because computer also have a limit of calculation. Software also has a limit of calculation. Your RAM, your hard drive, I mean, all of you would have understood that if you put very heavy image file in a PowerPoint presentation, for no reason your file becomes very large and then you have to use Google Drive to transfer it, right? But if you use low DPI or low resolution images in your PowerPoint presentation, you can screen it very quickly, you can transfer it very quickly, you don't require so much of computational power. Same way, if you make your model simple, it will use less amount of computation power. That means you will be able to generate more and more scenarios very quickly, you can compare scenarios very quickly, and you can arrive at the decision. Otherwise, if you really make a very complex model, things will become very difficult. Now, whatever I'm saying is an abstract. Let me put that into the example. I have drawn one block with 3 windows here, okay? Now we know that these 3 windows will have a different kind of heat transfer than my wall. Just an example, let's say my wall area is 100 and these 3 together is 10 plus 10 plus 10. So 30% of my area is window and total wall area is about 70. Okay. Now as an architect or engineer, we know that my elevation looks something like this. And if I try to model my building like this, it might take 0.04 seconds more. Now 0.04 second, it may look very too tiny for you, but if you are really making a large building, 2 minutes, 1 minute will really matter. Now as people who understand thermal dynamics or thermal heat transfer and other thing, we know that do we really need to have 3 windows? Amount of result, or kind of result which I am going to get here versus if I have a 70 square meter of wall and 30 square meter of window, result is not going to change, because amount of heat transfer to these 3 and amount of heat transfer to the same area is going to be almost same. Now why am I saying almost same? Because I have so much of aluminum and so much of glass Here glass area has remained same, probably aluminum area has changed. That much difference you are going to have in a heat transfer, but in return, your model is going to work much faster, much easier, right? And hence, when you look at the design builder, what it does, that it makes the window on its own, whatever the default value it takes, it's 30% or 40% or 50%, and it takes that almost same on all four sides. Okay, as an architect engineer, we will have a certain better control that no, I want to have more window on southern side. I need to always translate because I'm coming from northern hemisphere. So I probably don't mind having more windows on the southern side and less windows on the east and west side and so on and so forth. That is easy to make, but point I'm making is instead of replicating exactly what happens in a building elevation as an architectural elevation, you need to simplify your model so that your heat transfer calculation happens very quickly. Right? This is like one of the do's and don'ts kind of stuff. Okay? So that is what I meant by strategy. That, let me give you one more example. That I am doing let's say 20-story building. Do I need to simulate 20-story building? Yes, I need to model 20 floor building or 20-story building, but I may not simulate all 20 floors because floor number 2, 3, 4, 5, 6, 7 and up to 19 are same. It's office floor. Toilet blocks are in the same place, staircase is in the same place, elevators are in the same place, and otherwise there are halls, open plan space offices. What is critical is that I probably need to do this model, this simulation. I need to do one typical one, and I need to do the top one because I know that heat transfer on the ground and on top is different than this one. So what I'm doing is that I'm just taking 3 typical floors and simulating it instead of doing 20 floors. This also means that you may not model even other floors. Right? So that is what I meant by a strategy. That simply don't follow drawings which comes from architects and engineers office. They're pretty complex drawings. You need to simplify it for your energy calculation. Up to the extent that to me there is no difference between a drawing like this and a drawing like this when it comes to energy, because I know that what I'm concerned is with the U value of this wall, and I'm concerned with that this is also U value of the wall. Why do I need to see a thickness of the wall? I don't need to, right? Are you getting what I'm saying? So simplification is one of the strategy which you really need to adopt it. Sorry. Yes.
So all the other data, like from the stories and the thickness of the wall, you can upload it like writing it on the program. You don't need to like draw it.
That's true. That's true. That you can, if your floors are sort of they're typical floors, then you don't need to do that. Okay? Yes.
So, for example, in a room made of adobe walls,
Right.
I guess the inside volume of air will have an impact. So we should model the inside volume instead of the exterior volume.
Very good point. Design builder. Now I'm just adding one more dimension to what you're saying. Okay. Oops, sorry. Uh, let's say you have a I'm drawing a cross section. You have a one space having thin roof and brick wall, versus you have another space, same thin roof, floor space or rather outer dimension remains same, but you have a thick wall. Two things will happen here. Air conditioner designer will have a X volume of air needs to be cooled, versus here this X minus Y needs to be cooled, right? Because the volume has decreased. Although the floor plate has remained same, total bit up. Now what you are saying is that what is the area which design builder will calculate? Whether it will calculate this one or it will calculate this one. Am I getting correct? Okay, let me
I'm not sure about your question.
just hold on. So whenever I am seeing a 200 square meter in design builder, what is that 200 square meter? Right? Is it outside to outside, or it is leaving the thickness and leaving the thickness this side? It's inside to inside. I'll try to get onto internet, and I'm just trying to show you an image which describes this. If I don't get that image, I'll explain by drawing. Okay. So what it does, as you can see here, that I have a few more rooms on this side. This is my external wall. It will take outside of the external wall, but center of an internal wall. If I have more rooms here. If I don't have that room, then it will take outside of this and outside of this. So this is a thicker wall, this is a thinner wall. Same way, vertically, it will take bottom of my ceiling for this volume and bottom of that for that particular volume. But when it comes to a calculation for air, it will take only that yellow part. That's where the HVAC designers are more concerned with. Right? So does it answer your question? Or did I get your question correctly?
Yes, I think I stepped too far.
It's okay.
I'll let you explain more before I ask more questions. No, it was just a matter of then the width of the wall matters.
Width of the wall matters for the area calculation. Width of the wall does not matter whenever it comes to U value of the wall.
Right.
Right? Let me see if I can get one more. Yeah, here you can see if I have 2 walls, then it will take a center of the wall. Yeah? Okay, that's it. Now, the simulation gets used almost everywhere. Whether it is automobile or how my heart is pumping the blood, whether valve is going to help me or something else is going to help me. At the urban scale, climate change models, including GDP, including economic models on top of this. How people are going to move on the railway stations, on the airports, where they're going to get more traffic of the people, or what we play on PSP and Xbox and stuff like that. That's also simulation, and also it's sort of codification part. This is a bit of history, but what has happened that in terms of scale, there was a time when we used to, in a stone age, X was a sort of weapon, sort of meter was our unit, where now it has come to sort of really, really nanometer kind of, and that's where the simulation also plays major role. How do you really simulate certain kind of future scenarios and materials and so on and so forth. Well, I'll not go too much into the details, but simulation, it requires, at least energy simulation requires certain amount of equations to be solved. Now, certain equation which we really can't solve with the MS Excel, or it really takes too much of time, computer helps us to do that. As simple as this is a very schematic model of, just imagine 1 cubic centimeter of air somewhere here. And what is that air temperature? That air temperature is getting affected by amount of heat which this guy is generating, amount of, if at all we have a little bit of window, amount of air which is moving, what is the U value of this. So conduction, convection, radiation, at this point its view factor, amount of people we have, all that matters to that point. Now, if you want to calculate this through MS Excel or equation, it will be impossible, right? And that too dynamic. The funniest part is that if really I want to understand this air temperature here, and if I make some routines and write MS Excel sheets or whatever, probably it might take 2 hours, and by the time the air temperature will change, right? So that you really need certain kind of speed as well, and that's where the computer simulation helps us. And this is what the model is. Model is, as I mentioned, can be used at for multiple scenarios. And please make sure that you have that distinction in your mind, that what is a model and what is a simulation. Probably I'll not go too much into the details, but yes, all that, including how much energy I'm going to get from outside, how much is being used by HVAC systems or lighting systems, what is going to come from solar, what is the conduction, what is the convection, what is the heat transfer, all that, you can start looking at it. What is also very, very interesting, or what is very valuable, is that this is what is happening today. But I can have a multiple iteration based on multiple decisions. That somebody said, no, I just have $1 and I want to improve. Where to put that $1? Should I put that $1 on a window? Or should I put that $1 paint on my roof? Where is going to have maximum impact? Can come from iterations. How are you doing the iterations? If somebody said, no, I want to have more people inside the room, but I don't want to use more energy, then what do? Again, various kind of iterations which you can do. How do I orient my building? Whether my building, let me give you one simple example. I need to make 1,000 square meter building. I can make that building in a single floor plate like that, or I can make that building 100 square meter and 10 of them, which is good, which is going to make more sense in terms of economic or even in terms of energy usage. Probably you can simulate it, so you can model it, simulate it, and figure it out what's going to happen, right? Whether I should have a building orientation like that, or if I need to have building orientation like this, obviously this is going to be much better instead of this. Although amount of money which you're going to spend to construct is going to be same, but amount of heat transfer this guy is going to have versus this guy is going to have because of the solar geometry is going to be much lesser, right? So all that you can quantify once you start looking at the various kind of scenarios or iterations. So let's go on the design builder again. It's about 1 hour. We go for another 20 minutes and then, yeah? Okay. Any question? Before we switch to this, one more example of how simplification is going to help. We did see that yes, we are not going to model all of these. We will model this one, we will model this one, and we will model this one to understand. And then we said, okay, this is going to be get multiplied by 9, this is multiplied by 1, this is multiplied by 1, and then you can figure out what's going to happen. That's a one simplification. Similar way, just imagine that we have this corridor and we need to model this particular floor. What I will do is probably I'll have a corridor which is a different thermal zone than my classroom, right? Because I know that there are some parapet wall, this is exposed to the environment, and I probably need to understand this differently than what is happening here. But at the same time, I have a washroom block here, I have some kind of cafeteria or elevator block here, but otherwise, these rooms, the air temperature here and here is not going to be different, because somewhere it's written 21 degrees centigrade, right? So if I am operating that, even my windows here are same. I will model this as a one unit only. And I will not, otherwise what will happen is that computer will unnecessarily try to understand what is the heat transfer here, what is the heat transfer here, what is the heat transfer. Although this is 21 degree here and 21 degree here, result of that is going to be same, but it will still calculate. It doesn't have that kind of intelligence to figure it out that, oh, my set point is here 21 and set point is here 21, I should not do heat transfer calculation. It doesn't understand that, right? So that's also sometimes the difference between this one and this one is that I am not at all simulating these. I am simulating the full area, but differently. That's what the difference is. Okay? Why I explain this is because it's very important that we look at the typical floor space and how to do a zoning. And probably I'll have a slide for that as well. Let's figure it out. So what I was saying is that, let's say I have an office building, of floor space is something like, let's say square. I have one director's office, chartered accountant's office, clerical staff office, something here, something here, something here. People sit everywhere. Now this is an architectural layout. Assuming this is an air-conditioned building, assuming that each of these rooms will be operated almost in the same manner, I really don't need to make partitions like architectural layout, because it is unnecessary to do that, as we understood from here. But it is very important that we understand the thermal characteristics of this floor and model it appropriately so that we can understand how the building is behaving. What do I mean? Is that if I keep, instead of this, if I do this, as a result, what am I going to get is what is the air temperature here, what is the energy consumption here, and so on and so forth. Whatever parameters which I want to understand. All the results would be for this particular space or this particular thermal zone. Now we know that if this is a space like this, probably air temperature here is going to be different than the air temperature here during the daytime, because there is a solar gains, right? Hence I need to account that there is a window here. So to do that, assuming that this is all four sides open building, we divide the building into at least 5 thermal zones. Okay, these 5 thermal zones would be more or less like this. Now there is a huge difference between this one and this one. But what we are accounting is that because there are windows on these sides, about 3 meter to 4 meter on the perimeter, air temperature is going to be different than what's going to happen in the core. Hence, I need to subdivide the building in north, south, east, west. We call it a perimeter zone and core zone. Because this zone is not going to get affected by any of those sensible loads. When I say sensible loads, is that because of the U values or SHGC and VLT of the walls and stuff like that, right? This architectural drawing needs to be converted into something we call it a thermal zoning or appropriate thermal zoning. And this is very important. Once you do this, you will get 5 air temperatures, 5 relative humidity, and 5 cooling loads. How much cooling would be required in this space would be different in this space and then this space and this space, depending upon what time of the day and so on and so forth. Should I repeat what I say, or you're okay? There is a difference between architectural drawing and architectural partitions than a thermal partitions, right? Now, what you're doing is that when you make these partitions, we call it a virtual partition. They're not going to exist on the site. They're virtually subdividing the space only thermally. Just so, as in imagine that there is a very thin air here which is dividing this as a one thermal zone and this is another thermal zone. There is no U value here. Okay, there is no physical characteristics also here. So when next step in a design builder, what we will be doing is we will be making a partitions which are virtual partition. Now, let me not complicate the matter. Let's do that first. Okay. Then we will add a partition and virtual partition also, because let me not complicate. So can you just go back to your design builder screen, and shall I show you what is happening? So all of you are at this level now. What you need to do is that just go to at the building level, just check where your building is, and then go at the plan projection. And you don't see anything which can help you to draw partition here, right? Right now there is no icon which is showing you how to add partitions, because you are at the building level. Moment you go at the block level, you will be able to do that, right? You will see something here, and I will show you how to do that. But just look at it. This is a zone 1, and that zone 1 appears at the block level called zone 1, which has various walls and sort of windows and so on and so forth. We are going to draw a virtual partition without much of dimensions and stuff like that. Okay, right now we are not trying to replicate what exactly happens in a reality, but as I mentioned that the perimeter zone and core zone, the general thumb rule is that you leave about 3 to 4 meters from the perimeter, from external perimeter, and draw your perimeter zone. So this should be around 3 to 4 meters. That's the thumb rule. Okay. So what I'm going to do is that I'll go to add partition somewhere here. It's called Control B, right in the center, right top. Now when I go here, it shows straight line, arch, or so I'll standard or virtual partition. Okay, for probably let's go for virtual partition. So that means we are not going to specify U value of that partition. Standard partition, that means architecture partition, where you need to specify U value. Right now we are going to use this whole space as a one big space having various thermal zones in it. Okay, so what I'm doing is that virtual partition, you just go at one of the corner. As you have seen that the moment I select, let me go back, I'm out of any command. When I'm out of any command, my cursor looks like a routine cursor which you see in MS Word or any other places, right? My cursor design, the arrow, like any other normal arrow. But the moment I select, when I'm within the command, the image of the cursor changes to edit, which is like a pen, right? And when you are near to any object, now you are in a proximity. So even if my cursor is here, if I start drawing it will start drawing from this one, right? You are in a proximity of any object. When you go towards a corner, it will become green. That means you can pick up the corner. If you are not picking, if you don't want to pick up a corner, you can be somewhere here. You will pick up the surface. Here you will pick up a corner. Okay. So what I'm going to do is that I'm simply going to make a partition like that. I mean, right now I'm not too much bothered about dimensions. Now what is happening is that I made 3 partitions, right? 1, 2, 3, 4 and 5. Sorry, 5 partitions. Design Builder automatically recognizes that this is a virtual partition, and hence I need to subdivide thermal zones. So that this becomes one thermal zone, second thermal zone, third thermal zone, and you can start seeing that here as well. Okay? I still will finish my zoning. Do you want me to do it with you, or you will be able to do it on your own? Shall I do it with you? No? No, click here. No, click here, leave it, click, leave it, now draw. Yeah, so, sorry, some things which comes to me as a very obvious, probably I need to make it more explicit, that you click, leave it, draw, click again. Don't keep the click pressed. Now, if I have to draw it in AutoCAD, I'll press the left hand side, I draw and release. You don't need to do that. Click, draw, again click. Yes.
And partition type is standard or
You can remove your mask and help me understand.
The partition type is standard or virtual?
Version. I mean, right now you can make anything. The difference between these two is that standard means physically it is dividing, and you need to specify U value of that, versus virtual means you don't need to specify. It's a virtual partition. It's just making two thermal zones. So typically air condition engineer, what they will do is that zones which are going to get more gains, more heat gains, they will provide more air condition in that zone. Right? That's where the importance of the zoning is. Okay? Also, it's very important that you keep naming it. Although design builder gives you a block, zone 1, 2, 3, 4 or whatever, it's important that you look at your plan. Now you know where the north is. Zone 5 is a north zone. You click here. Sorry, you click at this place, leave it, automatically you will be able to edit it. Okay? And say north. Click outside. You can see only north zone here. Now you go to 4, leave it. This would be east. This is core. This is west. South. Now why is this so important? Is because when you get results, if results comes to that, okay, zone 5 heat transfer X, zone 2 heat transfer Y, zone 3 heat transfer Z, you will not be able to figure it out what is what. If you have named it properly, you said south zone heat transfer X, north zone heat transfer Y. Right? So although it is a little bit more clerical work, but it's important that we do that clerical work. If you go back to the block level, you will be able to see full. Okay?
Can I change the order of the
You can
labels?
Uh,
Of the like the southwest in a
so you want to see south at the bottom?
Yeah, like can I move
Why
it?
do you want to do that?
I don't know, in a more complex model.
No, so that's what I'm saying. Be extremely mean. Is that going to help you? Don't do it. Simply don't do it. Any ambition in modeling is going to kill you. No, it should look like a building. No, just focus on heat transfer. It should look like alphabetic. Why do you need to see alphabetically? Why do you need to see north, south, east? Yeah, there is certain way by which if you subdivide it, it will appear on its own, but you really don't need to do it. Okay. Now, last couple of things before we break is, if somebody say that my building this is what happens, all 3 pens are here now. If somebody say that my building is, sorry, sorry, 37 degree, not C, 37, how do we draw this? It will be like every time you make your screen like that and start drawing, it's very difficult, right? So there is a small functionality embedded in a design builder that don't worry about 37 degree or whatever when you're modeling it. Just model it in a cardinal direction. Most easiest way to do it, because your snap joints, the way a line appears is going to be straight and horizontal. Once you are done with your model completely, okay, go to building level, go to the project level. Now see there is a difference. At building level, I am seeing multiple things here. Okay. At the project level, I am only seeing where the project is. My layout, location, region. So if you want to change the orientation of your building, go to a project level, go to location, you have a site location, you have site details, yes, and you have site orientation. Okay, go to location and site details, the third gray drop down. Change this to 37, or even if you want to make it 37.5. Okay, say enter, go back to your layout, nothing has changed. What has changed is the arrow here. So it is still easier for you to keep working on those cardinal directions, only your north has changed. And this is one of those strategies of modeling, that just change the orientation once you're done with the geometry. Okay? Last point before we break is certain nomenclature which design builder helps you to understand what is happening, and keep this in mind all throughout the modeling activity. Let's say I am, if you go to location here, you see London, right? What do you see? And the template?
California.
Sorry?
California.
You see California?
I see
London. Interesting. Okay. Anyway, now there, if you click at Ahmedabad or whatever, California, London, you see location on the site, right? Just go to any location. Let's say we go to Peru. and it's Lima Airport or something like that. Okay, and I'll explain you that some point in time. Peru, double click. Oops, what's happening? Lima Calo Airport. If you double click there, simply at that point, that location will get recognized. Now what you're seeing here is all of them are in red. But if you see any other part, I'm just trying to look at where it could be. Anyway, because since we have changed it, but if you see something in a blue color, that means is a default, and the moment it becomes red, that means you have entered it. Red or red bold, that means it is entered by you and it is not a default. Okay, so when you open a new file, probably many things which you may see would be in a blue color. The moment you change it, that will become red. That's sort of another trick which you can. A third is the three dots which we saw on that license file. No, the extreme, the three dots is where you can select any other external files or enter any other value. So I'll show you that. I'll show you that when we talk about the construction, but one more tool related help is what you see here right now on my screen is snaps. No, as I was showing red and green snaps, so if you're closer to that, if you want to do the same thing for x-axis, y-axis, you can change that. Point snaps, sometimes it could be incremental, that 10, 20, 30, 40, 50, and it will not allow you to pick up 11 or 12. So the moment you say incremental step, it will say what is your increment you want to be. Sometimes we want to make buildings like 1 meter, 2 meter, 3 meter, 4 meter. If that's the case, you can always make this as a 1 meter. So every 1 meter you will get that snap and not 0.1 meter. Right? So the easier to sort of pick up some points. Again, you want to have endpoints, you have to met midpoints, edge snap, DXF. So these are the sort of drawing help tools. One more point, which is I forgot. Yeah, I forgot. It will come back. But let's break for 5-7 minutes. Yeah, 10 minutes. Okay. Any question? Yeah.
Thickness wall is always 0, or
You need to help me understand this.
or the thickness of the wall thickness.
How to assign it?
Yes, it's always.
No, you can assign it. So for example, let's say we go to building, block, I'll go to plan. I want to let's say I'm making a standard partition. Partition will not be able to get a ball, but let's say I'm adding a new block next to this, okay? And I want to make a block somewhere, let's say somewhere here. Oops. Now what you're seeing here, sorry, this I made an outline block, sorry, I'll explain you this later. But what is, let's see within this only. You want to change this thickness, right?
Yeah.
That will happen when you will look at the construction. Okay, now just this is what I want to show. All of them are blue. The moment you change that, anything which is default will appear in a red. So sometimes, some point in time you need to differentiate, right? So have I changed this or it is a default? If it is red, that means you have changed it. Right? You can change anything and you can see what happens. So for example, let's say flat roof, I pick up something else, now it becomes red. Thickness we can change it from here and I'll explain you when we do construction. Okay? Let's break. What's happening?
You're already succeeded.
So you need to get the building block.
Mira que tengo mi trabajo, eres más, mira, yo he pedido mi trabajo, pero como no, ni siquiera he podido sí, pero no es que no quiero mejor con la evidencia. Y soy surda, entonces...
Simulate before you go home today. Okay. How many of you want to spend at least 20 minutes, 25 minutes on your own, figuring out what's happening on the screen here on your own, and if you have any question you can ask. You want to do that? You want to have your own, whatever, 15 minute, 20 minute, 25 minute time on your own while I'm here? Or no? Okay. So that means each and everything you want me to tell you, right? She's saying yes. Okay. Very quick points about blocks, building blocks, component blocks, and outline block. I'll explain you what it is. Before that, you cannot open multiple files in Design Builder. So Word, you may have 3-4 files open, MS Office, PowerPoint. Design Builder will not allow you to open more than one file. There is a reason, because the calculation engine need to understand for which model it is calculating. And right now we don't have that much amount of sophistication in computer where you have one engine which is calculating but doing it for two outputs. Are you getting what I'm saying? There are two, let's say there are two files, and I'm saying that you calculate energy consumption. This file will go start calculating, then I said calculate for this also. Engine is only one, right? And once it is calculating, it might not be able to separate out the outputs for two separate models. So, I mean that much amount of sophistication is not there right now in the software. So, every point in time, only one file you can open and you can work on it. It's a little difficult for some people to understand, or rather believe this. I think they do understand, but they say, how come? But this is what the fact is. Okay? So what I'm going to do is I'm not going to close this file. If you want, you can close your file and open the new file, but I'm going to explain on this file only. What I'm going to explain is what we have done, or is a thermal zone. Now, there are two ways. Sometimes things becomes little tricky. One is that any kind of overhang here. Now, overhang modeling could become little tricky because you are trying to make some tiny overhang, and if you have like 300 windows, on each window you start making that, becomes a little difficult. So there are some automated way by which you can make overhang, but what I'm just trying to differentiate is that this overhang impacts the heat transfer on this building. The overhang which I have drawn so far is pretty thin one, but let's say architecturally this overhang is that big. A box kind of overhang. We don't want that overhang to become a zone, because we are not interested in what happens inside this, right? Why should I increase one more thermal zone in my model? The point is that I want to understand impact of a block on my zone, but I don't want that block to be simulated. Are you getting my point? Right? I want a presence. If I give you another example, I want somebody to be in this room, but I don't want to talk to it. That kind of scenario. So to do that, we have something called component block. Component block means it will have an impact on the zone or on the block, but it itself will not get simulated. It itself will not be a zone. Okay? So if I go back again to a plan projection, you can do the same. You can say add a block, add a new block, that plus sign with the blue blocks, and then what you see on the left hand side, block type here, right? You see three kind of blocks. One is a building block which we have drawn, second is outline block, and third is a component block. So let's go to component block. Autocomplete, standard component block, just keep it standard as it is for a while. Extruded, now extruded you can say 40 meter. Okay, and draw anything on a side here. That component block will appear as a pink color block. What does this mean? Is there is a building 40 meter height next to my 3.5 meter building. This building will cast a shadow on this building, but this building is not getting simulated because I don't care what is happening there. I just need to understand impact of that on my building, but I'm not interested in that building. That's what a component block is.
It's like working with like context.
Working like a context. Yeah, if I have a next building, how that building is going to impact me, but I'm not interested in that building. And same thing, we can do it as a component block. Sorry. Let's try to do that again, but today now we might use probably 0.1 as a height. We still can make it extruded, we can still make it standard, and we say block here. Sorry, I probably will change my axonometric. Now, what you're seeing right now on my screen, sorry, is just a gray building. Okay? If I go near to that building, one surface will become little bluish because it's the third dimension, right? That means anything which I do would be attached with that face. Versus if I move my cursor to this, now anything which I do is going to be attached with this face. Okay, that's how the surface is, the way green dot and red dot gets picked up, this is how the surfaces get picked up. Okay, now if you go here and start drawing what you have drawn is a shade on top of that window.
Repeat again, please.
Sorry?
Repeat again, please.
Shall I explain again? Okay. It's simple drawing technique. I'm adding a component block which is extruded. Okay. I need to draw the base of that. Extrusion means that if I draw 1 meter by 1 meter, and if I have given 3 meter height, it will be extruded like this. But if that 1 meter by 1 meter, if I do here, I can extrude it 3.5 meter this way. That's why I need to pick up the vertical wall. So I need to draw something here, and then I can extrude it. Okay. Try it on your own. It would be a little tricky, but once you get hold of it, you will be able to do it quickly. Now let's say I have drawn this, which is coming on top of my window. What I'll do is I'll go to that cursor green one. no command situation, I'll select this one, it will become red. Then I can move from here. If I click there, again if I go near to the point from where I want to shift, so the green dot, that means you are picking up that dot, and that is your reference from which your object will move, which will come again if I show you. I go to no command situation by going to this green arrow. If I want to check, I can check it on my canvas that what kind of arrow I have. I go and select the object. The moment I select the object, it will become reddish. Then you have multiple edit commands will appear. Earlier it will not appear. The moment you select, then and then these will appear. In that, the first one is a move. So if I select that move command, my cursor will change to a sort of crosshair cursor. The crosshair cursor goes near to the object, and if you go and pick up that green dot, from where onwards you will be able to move that to whatever point you have. Now because I have given a snap, it has directly picked up that vertex. You remember the snap, the settings? There it was given that you snap it to a vertex. If you don't do it, then it will remain halfway somewhere. It all depends upon what your settings are. Now same thing, again, still I'm within the command because the block still looks red. If I put escape and click, I'm out of it. Okay. Let's say again the kind of component block which I wanted, I have made a wrong geometry. I'll select it again. I'll go back to something called let me go back to stretch object. Okay. Now whenever I go to the surface, I'll get a stamped kind of icon. That means that red perimeter and the stamp, I will be able to click there and I can push this up and down. Now right now I am seeing this whole thing as an incremental 1 meter, because if you remember that the snap, I did put 1 meter as my snap increments. If I need to change it, I need to go there and change it. So this is how, even after making a component block, little bit wrong geometry, if you want to stretch it, if you want to shorten it, you can do that. Okay. Escape, you are out of it. I'm just deleting this for a while. Okay. But this is what the value of component block. Again, I'm repeating, what is a component block? Component block does impact the building, but it itself does not get simulated. It itself does not get changed into zone. Yes?
This component block has also properties, for
This-
example, color.
Right. So this component block, if you look at it here, double click, and if you go here in a construction and say drop down to construction, the question is that does this component block has a property? Yes, it has a property, but it has very, very limited property. What is that property? Is that it can have only surface, position and maximum transmittance of that, which is basically you can have a surface property, you cannot have any thickness related property. What does it mean? If I am making a building and if that building is completely glazed, and if that glazing is putting some more radiation on my building, it will get accounted. but that glazing will not have any conductivity. It will have only surface property which is of radiative property. Okay?
One question.
Yes.
And we can upload, I don't know, from another software like Windows, the one that gives you the properties of the glass. One can import the properties there, or
You can. We can. What we are going to do is that, depending upon how are we going to move, there are three things as I explained, which we will be dealing with. One is, right now we are dealing everything to do with the layout, which is we are dealing with geometry. Activity, construction, opening, these three templates we want to deal with ideally by tomorrow when we finish. So when we do a construction part, I will be able to address your query at how to import, what to import and stuff like that. But right now answer is yes, you can import. Okay, let's go back to the block level and sorry, I'm deleting this one. And now I am trying to put a new block which is called outline block. Okay, same place. Here we had a building block, component block and outline block. Okay, outline block is something which can be seen as an intermediate block, especially when you have a geometry which is a little bit more complex and you don't want it to be zoned all the time. So what I'm saying is that, let's say I have some triangular shaped stuff, or I have something which is little difficult to model or in terms of its geometry. I can work with the multiple shapes, multiple guidelines, make the outline block and then convert that into the building block. That's one of the function of outline block. So I have selected outline block here. I am going in a plan. I am doing something like this. Sorry, I was in a rectangle mode. I need to get to non-rectangle mode. I'll go to polygon. I'm making something which is now what you see here is that one 10 centimeter thickness, which I forgot that I should have changed it. So I select this, I stretch the object to whatever level, right? And then I select this and say convert selected outline block to blocks. Okay. When I click here, it will say you want to change it to building block or you want to change it to component block. If you change it to building block, it will become zone. If you change it to component block, it will get impacted, but it will not get simulated. So right now I am saying is that let me make it a building block. You got another building, you got another block, and it has single zones so far. So, outline block is one of the function of outline block is intermediate geometry making. It will not keep making your zones until you are satisfied with your geometry. Second function, which I'll show you now, and for that I might need to try a little bit differently. Yeah. Okay. Now, see, my cursor is near to the vertical surface. Okay? And I am in a polygon mode. I am drawing a polygon, something like this, and I got sort of triangular place on this side. What does it indicate? Is that I have outline block which is not a zone, but it is attached to my building, which resembles that your building is situated on a slope. Somebody has made that part flat, but sides you still have a slope. So heat transfer in that triangular part is going to be different than heat transfer which is exposed to the air. Can I tap this or it will get detected?
No problem.
Huh?
So, yeah, no problem.
Okay. With electronics, you don't know whether something will happen. You tapped it, it will crash. So, component now, one more point which I am showing you. But keep this in mind that if you have something which is part basement, no, I can go rotate this. I can add another component block here. And what I'm trying to do is that I'll say, okay, this is a building which is on a slope. Back side of the building, the rear side of the building is half in the ground. That side is not in the ground. This side is not in the ground. This is partly ground. What you see here, this is that means, let me go and change the orientation, otherwise I get confused. I'm going back to that north. This is our 5-zone view. If I just want to look at one zone, and why I want to look at that is that you see something here which says adjacent to the ground. That means my floor is adjacent to the ground, and there is some kind of heat transfer taking place, or conductive heat transfer taking place between the floor and the ground. what is attached with the ground? This is showing us that this surface is attached with the ground. If you look at the east side again, it shows you this is attached with the ground. So whenever you see this mark, that means that's a floor which is attached to the ground. If I make this first floor, I should not see this. Okay? So this is a check, a visual check which you can keep checking whether your building is on the ground. Sometimes your geometry, you're drawing something and you, by mistake, you draw a building which is like 3 feet above the ground and you don't know whether it's touching the ground or not. Because the graphical interface is not so sophisticated, right? So by checking this, you can figure it out what's there on the ground. At the same time, Argish, I need your help if you know. How do I make a part wall adiabatic, no, not adiabatic, adjacent to the ground in the component, in the outline block? Okay, I'll figure it out. Okay, I'll come back to you on that. But basically, what you need to do is that we need to define that this block is also earth or a soil, and hence that adjacencies, which you were seeing the green triangle, you should be able to see it on a wall as well, part wall. That means that much conductive heat transfer is taking place between wall and the side soil or grounded earth, right? So that's what the adjacent to the ground is all about. One more thing, which let me see if I can show you right away. Otherwise, that we will reserve it for construction purpose. Yes. Sorry, I forgot. Now, let me go back. We are in the layout. We are somewhere here. Okay. In this earlier, when I was looking at this particular zone, which is north zone, where outside I have a soil, I should be seeing the way I am seeing agencies, ground agencies here, I should be seeing a ground agencies here as well, because partially it is outside, which is on the ground. I need to define that, because outside is my outline block. Outline block is not been defined as a soil, and I cannot define it as a soil. But my wall, I can define it is next to the component block, which is of soil. To do that, what one needs to do, just select this wall, select that wall, go to construction here, look at this adjacencies. Instead of auto, you said it is adjacent to the ground. Okay? You go back to the layout, and then now you will see that particular triangle here as well.
Excuse me, can you repeat?
Yeah. So, point, did you get why we are doing this?
Yes,
You don't know how to do it?
I don't know how to.
Okay. Select the wall. Go to the zone, and if you are finding a difficulty in selecting a wall, it's easy to select a wall from here. Just click that wall, this will get selected. Yeah. Go to construction. Find the drop down of adjacencies. Instead of auto, you said it is number 3, adjacent to the ground. Yes? You're done. Go back and check whether you see that green triangle stuff.
Yes.
Okay.
That means wherever there is an outline block outside, that part of the wall, there will be conductive heat transfer with the soil, and otherwise the rest of the wall is open to the air or open to the climate. Now the question is, what would be the temperature of the soil? That will get defined by something called weather file, and I'll try to explain you that later on, if I get a time. Okay? So this is where adjacent to the ground needs to be defined, something which is half ground or full ground. If you're making basement, you can have this green component block or green outline block on all sides and bury under the ground. You'll not believe that if you simulate and if you try to look at it, you might see that probably 15, 30, 20% or more heat gets lost to the ground, because ground temperature and room temperature, there will be a considerable difference. Okay? Hence it's important that you define a ground connect. Second point is, let's say I have another building here. Instead of ground, I have another building here. And for some reason, I want to make sure that this particular wall does not do any heat transfers to the second one. Okay? That means I need to make that wall adiabatic. Adiabatic, that means no heat transfer whatsoever. Conductive, convective, radiative, nothing. To do that, you go again, the same agencies drop down and say adiabatic. Go to the layout, and you will see this kind of reddish sign. That means there is not going to be any kind of heat transfer between this wall and what is happening outside. Now, one way you want to do it is that you don't want to consider additional ground heat transfer, because you are in a very, very early design stage. All of this will matter at what stage of your design you are. Right? If your architect is just sketching it out and you don't want to do too much of calculation, you say that everything is adjacent. Or sometimes you may be given a project which is of large building, multi-story, and only this floor is of your client, and you say, I don't know what's happening on this floor, I don't know what's happening on this floor, I can suggest interventions or HVAC systems or an insulation or lighting or whatever only for the wall area which we can do. We can't do anything with the floor, we can't do anything with the ceiling. Whatever intervention we can do is only on the perimeter envelope. In that case, you don't want to simulate anything, or you don't want any kind of heat transfer here and here, right? Because otherwise, if you make your model, like what you will do, you will model like something like this, but you will make this and that as a adiabatic. If you don't make it adiabatic, there will be air, then it will be seen as a building in the air. So whatever outdoor temperature or outdoor humidity, wind velocity, everything will affect your building. You don't want that, because you want this to act as a intermediate flow. And hence, at least top and bottom needs to be made adiabatic. This is where you use this command. And you say that all my interventions I am proposing only through the envelope, because we can't do anything up and down. Yes?
One question, and the heat transfer between, I don't know, the next floor or
Your floor.
down the other floor, there is no analysis there?
You can do, provided you have a data. See, if I know what is the air temperature at that floor and what is the air temperature at that floor, if you define it, you will be able to calculate heat transfer. That means you need to go and ask that person, where do you operate your building at 24 or 21 or 26? If he gives you that understanding, and if he really operates that way, you don't need to make it adiabatic. But generally such things are not, let's say, so nobody has occupied that building. Your client is the first one to occupy this floor. Where will you get the data from? Right? Also, same thing, this is vertically. Same thing we also can do horizontally. Let's say I have number of shops. This is a plan. It's a number of shops. I don't know what's happening in this shop and what's happening in this shop. I need to make this wall and this wall as a adiabatic instead of floor. I mean, whatever I'm explaining vertically, same thing happening horizontally. So this is where you use adjacencies command to make it no heat transfer or calculated heat transfer. Yes? So last two things which we did. One is component block and outline block, and second is this ground heat transfer or adiabatic. Yes?
When we define that wall as adjacent to ground, are we defining the whole wall or only the part that is adjacent to the outline shape?
You need to define whole wall. Model will understand how much is outside, because that outline block is touching only half of the wall. That model will understand on its own. But you need to say that outside that green block, what is it? It is a water body, or it is a soil, or whatever it is. Then geometry will come into the picture and say, okay, 50% of that is with the water or with the soil. Yeah. Otherwise, you need to make two walls like this. One wall which is adjacent to the ground, another wall which is adjacent to air. That capability Design Builder Energy Plus does not have. For the one zone, you cannot have two walls on top of each other. Right? Yes?
So understand better the question. So if you have like the half of the wall in the ground and half in the air, so you have to simulate like two blocks.
No. You need to define, as we have defined it here, as that we have defined it here, that outside this I have a outline block here, and rest of the wall is open to the air. That has been defined as a geometry. Characteristics of this wall, you said it is adjacent to the ground. And looking at character which you have defined and a geometry which you have provided, Energy Plus or Design Builder will understand how much is exposed and how much is not exposed. Right? Now, if, let's say, and this is where people gets really into the, for no reason they get into the details. Somebody said, no, I am an architect, I have designed a wall up to this extent is RCC wall, this onwards is a rammed earth wall, how do I model it? U value, a conductivity of this is different, conductivity of this is different, you can't model it. Model it the way site is going to behave. But you can do it with a bit of pre-processing. What you do, what is the area of my wall which is below the sill level, calculate what is the area weighted conductivity, same thing you do it here, area weighted conductivity, normalize it and say that my whole wall is having this amount of conductivity. Then you can do it. Right? So, I mean, what point is that you really don't need to get too much into the architectural aesthetics kind of things. Just stick to the building physics. What's going to matter? Okay? Last half an hour. Yes?
Can I make
You can.
Can I make a thermal zoning in vertical?
Sorry, come again?
Can I do the zoning but in a vertical way? Because we have done it horizontal.
What do you want to use vertical?
Because well, we could have like this ceiling, so the air that is above is different than the air that is on the ground. So I don't know if in vertical you can do.
Oh, okay.
Classification.
So this is within the floor space. Within the floor space, you are saying that the way we are dividing the floor plate into what you're saying is that the way we are dividing floor plate into horizontal, you want to divide bottom and top.
Yeah.
Is that the case?
In vertical, yeah.
Vertical, yeah. So this room, below the desk and above the desk, no, you can't do that.
But the air is different. I mean, if I have like an equipment in the ceiling that makes, I don't know, the air more cooler,
Yeah.
it will alright. Like this very warm and the bottom cool.
Yeah.
It should be, I don't know, I think it should
No,
be
that's
able
you.
to-
The fundamental is in place, right? This model cannot do it. If you want to do it, you will need to go to something called computational fluid dynamics, which actually will help you to spatially understand. Now, this is where how much effort will you make, will you do to understand only this much, right? Because computational fluid dynamics is reasonably complex. Correctness of that is also very difficult to achieve. Computational power is also required. So it's all depends upon how much can you really put effort for what result you're going to get. Energy Plus or rather Design Builder will give you all homogeneous air in that space. There is no, if you want more, you can subdivide this space vertically, sorry, horizontally. But whatever zone you are going to get, it will assume that the entire zone have a uniform air in terms of temperature and relativity and errors. Right? You want to add something, Rakesh? Okay. But yeah, vertical, like for example, you say that, I have a false ceiling. So I have a floor, 2 feet of false ceiling, can I divide something above that and something below that? Okay, geometrically you cannot, but we call it semantically. That means with data you can define that that's a plenum for HVAC. All my return air gets accumulated in the plenum and goes away. That you can define, but not in a geometry form. Okay. Any other question?
So that part will be each in
So
each
more question, that means you are delaying the simulation, okay? Yeah, please go ahead.
So that part of the like we have a ceiling, we will going to see in HVAC, right?
Yes.
Okay.
Fortunately, this is not my routine class, although I don't teach much, but in my routine class in the university, I'm known as a professor who just allows 2 questions to ask over the semester. It's
Per
true.
class or per person?
Per person, per semester, only 2 questions a person can ask. The reason for that is 2 things. One is that this normalizes the, if at all there is a diversity, and people will think before asking. Right? I don't know how much of you follow the cricket, but in cricket we have something called DRS. That means you can ask umpire only twice or thrice. That means you will ask question if really you are struggling. And simulation is a subject, and if you struggle on your own and if you find it on your own, you will learn quickly and you will never forget. Right? Although that rule doesn't apply here. So we have no idea what is the inputs we have done, what is the conductivity this building has, where this building is, who is using. We have no idea, but let's say simulate it. We generally don't, I mean ideally you should not simulate until you model it up to the full detail. Okay? When we do simulation, the design builder, all this geometry and all this input will go to the Energy Plus. Energy Plus will calculate, will throw the results, and finally you will be able to see the results. People always have this tendency across the world that they want to specify minute detail. Don't. People want to understand what is happening every hour. You don't need to understand. At very beginning of the design stage. Yes, after certain point in time, you want to get into details, but how much effort you are putting at what scale? I mean, if architects are designing and they are making a form, they really don't get into the details of plumbing at that level, right? Do you ask an architect when they come up with a bubble diagram or whatever, they say, where is my plumbing line or where is the manhole? You don't really ask that, right? So, same thing applies in the simulation, that if you are at very early design stage, what you want to understand is what happens in a full year. If you are in a little bit more detailed stage, you want to understand what's happening in the winter and what's happening in the summer. Little bit more what's happening in the morning, what's happening in the afternoon. And depending upon that, you will slowly start taking a decision. Now, why it is so important is that although computer is a simulation, the computer simulation is sort of run by a machine, but it has its own requirement to calculate. If I want to understand from day one that what is happening in my building over that entire 8,760 hours of the building, of the year, where my outdoor outdoor conditions will have at least 16 parameters, relativity, radiation, diffuse radiation, global radiation, or many things. And inside I want to understand what is the energy consumption or temperature or relativity. Just look at how many parameters you are going to look at. You really don't require that. Okay, so we call something like a time step. At what time step you want to simulate? Easiest is that you just look at what is happening across the year. Start with, then slowly come down. Simulation or calculation time is directly proportionate to the amount of detail you ask. That's number one, which is sort of common sense. But what is little unique is that to give you, if you ask for one thing, computer is still going to do all what it's supposed to do. So in terms of calculation time, it is going to calculate everything because this one number is depending upon all of these. But difference is reporting it. It will calculate everything, but it will only report one thing. If you ask it to report 100 things, then your time of computing will increase drastically. So what point I'm saying is that the computer takes more time in reporting. It does calculation, whatever it is supposed to do. But to extract things out of all that calculation and give you 100 parameters for you to look at, it takes more time. But if you ask for only one parameter to look at, very quickly it will fetch it out and give you number one. And just hold on. Let me check. Okay. Now, sorry, I was in little different screen size, and hence we were not looking at what is happening at the bottom as well. So when you are at the building level, you will see some more stuff here. One is a visualization, is basically whether your building is appropriately modeled or not. You can simply check it. If you want, you can look at the render view. This is a more realistic view, but otherwise little simplistic view which can show you what are the project walls and what are the ground floor and partitions and so on and so forth with a color coding. Then there is something called heating design, cooling design, basically sizing of the air condition. Whether you need do you use tonnage as a unit or kilowatt as a unit?
Kilowatt.
So how many kilowatts do you require to cool or to heat? Kind of calculation takes place. We are not getting into details of that. We'll simply go to a place tab called simulation. What's happening? Okay. Let me update the data. It's possible, otherwise it will ask for something. Yeah. Now it is, the moment I hit the simulation, it is asking that what is the start date, what is the end date, during what time you want to simulate. And this is not the ideal simulation time frame which you provide. If you are in a very early design stage, you said, I don't want to understand what's happening across the year. I just want to understand what is happening in a peak summer or peak winter. And if I try to manage myself at the peak outdoor conditions, I will do some kind of interventions. Then I will do certain kind of thing. Then finally I will look at the entire year. So you can decide the time frame here. There are multiple other options. I will come to that in a while. You can also decide what is the output interval for reporting. Here it will report monthly and a run period, daily, hourly, sub-hourly. We just want to look at it, let's say, let's for example look at the monthly, let's look at the daily. No, it depends upon what I'm doing. There are some other options here which we'll look at it tomorrow. Let me simulate right away, and I can, instead of going for entire year, I'm just looking at summer typical week. What you're getting here is the different kind of time period for which you can simulate. Annual simulation for entire year, summer design week, that means sort of peak week for which you design your building, right? In a seismic engineering, you said you design it for earthquake level zone 4 or zone 5 or something like that, which is like peak conditions for which you design. Peak condition could be different from typical conditions. Typically what happens is different than what happens in the peak. So let's try to look at the summer peak week, and again sort of same thing for the winter. And the moment you select, looking at the outdoor weather file, and I have not explained you what is outdoor weather file, probably we may do it tomorrow. For that particular location where your building is situated, design builder will automatically calculate what is a typical summer week for that city you have. So if you are doing something in Lima, it may appear 19th February to 25th February. But if you are doing something in Ahmedabad, obviously the northern hemisphere, something will appear in April or May. Right? So it will automatically detect from the full year data that what is a typical summer week. Okay? Once you do that, you say, okay, oops. The latest version of My Energy Plus was not installed, so I'm just downloading it. It may happen with your machine, maybe, depends. Now it is initializing, and what's the,
So,
sorry?
you have opened the Energy Plus?
No, that's an old version. Now, we did see all those cities, right? When we were picking up the location, we looked at all the cities. The data of all that cities does not get downloaded when you download Design Builder, because otherwise it will be too much unnecessary data. I mean, you are working in Peru, why should you have a data for USA? So, but when you simulate, make sure that you are connected with the internet. Design Builder will automatically go to Design Builder server. It will fetch the data for Lima. It will download it on your Design Builder, and it will calculate for Lima outdoor weather file. Okay, that's why the one warning came and the Lima weather file was not available. Can I go and fetch it? He said, yes, fetch it. It has downloaded that. And what you are seeing right now is a sort of result. Now, what do you see in this result? The number of things which is coming up. And let me try to look at one of the things which is probably may interest you a little bit more. But before that, here is a selection pane. Do you want me to go slow? No, okay. This is entire year data from, let's say, no, this is for only for that week. Okay, 7 days data from 19th February to whatever 25th February. You will see 2002 here. 2002 February here at the bottom. Don't worry about the year. Something needs to be provided, hence 2002 has been provided. It could be 2009 also, it could be 2019 also. But what you are getting is of the February of that particular date. Okay? Let's try to look at what's happening in this building. And to do that, instead of looking at all data, I'll say I just want to look at internal, no, let me Yeah, let me look at the internal gains, or let me look at the, yeah, internal gains. And I also want to look at not, probably, let me look at 2 days, normalized by area, or probably we can, let's look at 7 days. Okay. So what is happening? You don't see much here. More or less things are flat, and this is what we expect in Lima, that because your outdoor condition doesn't vary drastically, you don't see up and down all the time. Okay, and this is happening at the daily part. Now just remember, what we are seeing here is a normalized data. Now, if you look at the yellow, it says a solar gains exterior windows. Okay? How much solar gains are you having from external windows is the number, and it is sort of remaining constant all 7 days. Because we did ask the design builder to report on a daily basis. Okay? And it has normalized to the daily basis. Let's look at it hourly basis, and then we might be able to see some kind of change in the solar gains, because sun will rise, sun will set. Depending upon hours, this gains will go up and down at the building level, not at the orientation by orientation. Okay? Now if I go to hourly basis, it needs to simulate again. It has to report it again, not really simulate, but report it again, and hence I need to update the data. You see, now it's taking a little bit more time. And what you see is so what are you seeing is again at the all 4 zones together, or all 5 zones together. Okay, during that time this yellow line is going up, dropping back, going up and coming down. This is summer. That means that solar radiation falling on the surfaces will reduce when your sun is right at the top. Right? If my sun is at the lower altitude, I am getting a lot of radiation from all sides. Sun is going up, that means my radiation drops, sun comes down, radiation increases. Now same thing if you see it in a winter, probably sun moves more like this, you might not see this drop. Are you getting my point? Are you aware about solar geometry? More or less, Martin? Yeah? Are you getting what I'm saying? I mean, how are we? You don't see sun here, it's a cloudy, right? I mean, that's not why.
In February we do.
Sorry?
In summer we do.
In summer you do, okay. But are you getting point which, why is this drop? It's primarily because the angle of the sun is on the rooftop and not on the sides. Right? We are a little more closer to that. I mean, if you go to Johannesburg, or if you go to right up to Edinburgh, you will have a lot of solar gains because the angle of the sun would be much lower. And there you might see almost this going up and down. Let's try to see what happens in Ahmedabad immediately after this. Okay? What you see is this is a zone sensible cooling. Now, we have not defined HVAC system, we have not defined air condition here, right? Design builder automatically default, it will take that, okay, I am generating all that kind of heat. I need to balance that heat. I need to reject that heat, hence I need to provide certain kind of cooling so that my heat balance becomes 0, 0. That's why you see this in minus. All these 3, 4 lines, this is occupancy. Why occupancy is dropping in the afternoon? Because people had gone for lunch. Less people are in the room during lunchtime. Something has been defined in the occupancy schedule, we'll see tomorrow. What is this? It is a computer and equipment which are almost constant. People are going out, but computers are on. That's how it's been defined. So all this heat which you are seeing here is being extracted out by sensible cooling, and this is what the total sensible cooling you are seeing. The drop in this gets reflected here as well. During that time you need less sensible cooling because people have stepped out. Right? So this is basically heat balance, and this is what the result which you get out of very basic simulation model. Good night.
Excuse me for the question.
Number 6. Yeah.
Well, in HVAC we use always BTU hour. How do we change it?
Oh, here?
Yes.
Oh, you want to change the units, right?
Yes, change the units.
It's not possible. No, so you go at the building level. Sorry, at the unit level. Okay, sorry. We need to go to the edit. Go to spanner. Just hold on. Now I just need to get to. Yeah. What you do is that you go to tools, go to options, program options, go to international and change from metrics to IP or IP to metric, whichever way you want to change.
Okay.
Yeah? So, I'm stepping out, we're locking you in the room, run as many as simulation you want to run, we'll see you tomorrow morning. Any question?
Can we export the data?
Sorry?
Export the report, sorry.
You want to export, you want to analyze on your own, right? That's what you said, right?
No, just export the report. But
Export the report, yeah, the number of ways which you can export the data as well, because we don't like what design will show you green, yellow and stuff. It's a bad color palette. You want to have your own graphs, you want to own your regressions. You can export data into MS Excel itself. Okay? What I always tell is that it's impossible to teach simulation. Impossible. I mean, even if I spend 6 months here, I don't think that I'll be able to translate. What is possible is to let people know that this is possible. For example, you can export. You can export in MS Excel. The moment you get this clue, it's very easy for somebody to figure it out. Either you Google it, YouTube, whatever. I mean, you just need to know what is possible, what is not possible. At the moment you know, I'm sure that 99% of you will be able to figure out how to do it. Okay? Do you want to, I want to break for a day. Do you want, or any other questions? Yes?
imagine
Right.
that our client.
Question number 36, yeah.
Imagine, well, I am a mechanical engineer, so my clients gave me the their like there's like their models in other software, like in other software, like I don't know, maybe Archicad or other programs. So I can import the like documents here in Design Builder.
If I translate your question
Yeah.
a little bit, what you're saying is that architects, MEP engineers make their BIM models or make their drawings in AutoCAD, Archicad, Revit, MiniCAD, whatever. Can I bring those models here?
Yeah.
Is what your question
Yeah,
is.
that's the question.
Yes. You can bring the drawings here,
Okay.
not model. Let me give you an example. Architect will draw plan something like this. Okay? That's a room. That's the thickness of the wall. That's a door. This is how they draw. Or sorry, this is how I draw. Okay? Design builder doesn't understand. Why do you need to understand how the door opens, right? Design builder just need to understand what is here. And hence, cleaning up those drawings for design builder to understand takes probably 5 times more time than to redraft it again. Because those drawings have so much of information. They will have sort of dotted line. What is this? This is a beam. Oh, design builder doesn't care whether it's a beam or not. So that means if you want to bring that, you need to delete these 2 lines. So it is possible. A lot of things are possible. But should we be doing it? Probably no. Right? If you are very much interested, there is something called IFC, which is Industry Foundation Classes, which basically is trying to find a common ground where various kind of platforms can be put together and still make sort of sense. So, like I can open my Coral file into Adobe, or I can open PDF into some Acrobat PDF into some other PDF reader. So there is an interoperability is been defined for Revit and Design Builder, or for Archicad, MiniCAD and Design Builder. For energy model, that kind of interoperability is not been defined very well. And hence right now it's easy to draw again than to clean it up. Yeah?
Thanks.
However, last one. If you really are desperate because that drawing is, it's so complex design, you can still import by going to import and say DXF import. Just hold on. I probably need to open a new file. Yeah, import 2D drawing file, and then you can import, there is something which is very data export file, DXF file. All CAD softwares do export to DXF format. Once you bring the DXF format, what you will get is a two-dimensional drawing. On that you can redraft it to make it third dimensional and then delete the base drawing which you want. It's possible. Through this it is possible. But not like three-dimensional BIM model cannot come here. Yes.
I have my second question. How can I make a hole in the middle of the building?
What kind of hole you want to make?
If I want an open space, parallel with the building. So in model.
So the question is that how do I make a hole in a building?
Yes.
Let's say I have a building here. And you are saying that I want to make a hole here.
Yeah.
Right? Sort of courtyard. Is a courtyard word gets used here? No. Right? What is happening is that even if you want to do this, you want to make sure that this zone, this plane is defined. For me to keep something like this open-ended, you will not be able to simulate, because what is your thermal zone? Is that your thermal zone? How big is your thermal zone? You don't know. So I need to close it here, right? I can close this with the air, with a 0.000001 millimeter of air. But I need to close it. And I need to define what is this air doing. What is the characteristic of that air? Thermal characteristic of that. Once I do it, you can consider this as a hole. But you cannot have a hole which is like open-ended hole. For example, another way, I cannot have a window which is open window. I need to define the window which is open, but there is an air film here which will allow certain kind of air to move in and out and certain kind of heat to come in and out. But I need to define what is that film. Right? Geometrically, it is possible to do courtyard. There is a model. In fact, if you look at the example files, there are a lot of example files been given which has predefined models available. So what we do generally, what I suggest my students to do it, that you get that model, delete the geometry and make your own geometry. But model means that everything is defined. Construction is defined, temperature is defined, activity is defined, everything is defined, geometry is not defined. So what are these templates? The other templates which I am saying, oops. Now, in your file, you will be able to see some. If you go to block level, you see some templates here, activity, construction, and so on and so forth.
Yep.
That is non-geometrical data. It's a semantic data. So what you do is that there will be a example file here called courtyard. You open that file, you can change the geometry the way you want. Everything else is defined here. And you can use that.
Maybe new document.
Sorry?
New document.
New document. That's good.
Oh,
Thank you, Ryan. We will see you tomorrow, 9 o'clock.
Let's see whether they will turn up or not.
It's in this building, but in other.
501.
Yeah, 5, yes. Han marcado, han puesto su firma, resistencia. Si alguien falta,
Acá está la hojita.
Si hay una hojita ahí para tomar nota.
And we did not further got too much into the details, how to analyze it and how to look at the results and stuff like that. We'll do that today. Probably just before lunch or after lunch. The plan is that for another 90 minutes, I will show you a few more features. Then we'll have a break around 10:30. Again, we will come back some more functionalities and features. We'll go on until 1 o'clock. Then we'll break for lunch. After lunch, then just before lunch, I will introduce some exercise which you can do it on your own after lunch. And between 2 o'clock and 3:30, I'll be simply sitting here available to you if you have any kind of troubleshooting, but you will be doing things on your own most of the time, right? And that will give us a little bit of understanding that whether you can kickstart your journey on a simulation. So that's what the plan is. I would be happy to change any point in time if you feel that no, probably we need to change the course. In between, probably about 10:30 when we come back, I also will request one of my colleagues to talk about some thinking going on to establish some kind of, we call it a group in Peru, which works on simulations. We call it an international chapter of International Building Performance Association and chapter within Peru. So we'll talk about that as well. And some more resources. I mean, I'm here to show you what all is possible. So immediately after that, I'll also show you. If you have trouble, if you want to know what's happening in the world, if you want to learn something, what are the web resources available? So we'll expose you towards that side. So that's what the plan is. Arvish, you want to say something?
Yeah, yes, and I'll probably have to repeat that if the room gets fuller. So after like at 3 or 4 o'clock, if any of you decide to stay over, I'll have to say that between 4 to 6, we have a number of presentations from the students that we've been gotten here in the university. They've been given a software that you're using, or the back engine of the software that you are using, which is now coupled, we have coupled it at UCL with QGIS, a geospatial software. And they've done some field work during the week, collecting data from a few informal settlements around the city. Well, actually, it's just one, it's by itself, it's just a few different building blocks. And they'll be simulating that, but not only the base case, which is the current state of these settlements, but also they'll be doing some sort of suggestions in terms of refurbishment, retrofits, and improvements in the buildings. And they will be presenting that between 4 to 6. It would be super valuable for anyone from practice industry here in Lima, or indeed any other entity body that is involved in the design of buildings. It would be super interesting if you could stay over for a little while, have a look at these presentations and contribute and connect with the students. But I know what I'm asking you is really to say from 9 until 6 p.m. here, which I'm pretty sure on a Saturday might not be ideal. But if you can consider that, then I think the students and ourselves would be grateful.
Thank you. Thank you. So we can you put up? I don't want to really shout. There is in a lighter tone, there is a joke where somebody asks someone that whenever you see any kind of train accident, most of the damage happens in the first, immediately after engine, the first coach or bogie, what do you call it? Coach? car, first coach, first the number of coaches, right, in the train. Okay. So most of the damage happens to the first one. So what is the solution for that? So the one person simply said, put the first one in the last. So even if you're there, you will get damaged, so better you come here. So that at least I don't need to shout. Anyway, we were discussing yesterday and we did simulate a small building for full 1 year. You will wonder that what are the outdoor conditions is been assumed. We did see that Lima, Peru, Lima, an airport file, something like that, and you selected that. That file was not on your computer got connected to the server and got the file on your computer. So next time if you are offline, that file is available in your computer and you will work. But what is that file? What is there inside the file? We call it an outdoor weather file. And this outdoor weather file, the technical name is typical meteorological year. Okay. It is not a file which says that what is happening outside in 2021 or 2020 or 2019. Right? It is typical year. Okay. That means from probably 1970 to 2021 or sometimes 2011, depends, someone has set and looked at each year, year 1, 2, 3, 4, and each year has about 760 hours, 16 parameters, that is degree centigrade, relative humidity, radiation, wind speed, and so on and so forth. For each year, for about 40-50 years, somebody looked at the data and said that let's say we have 52 weeks. We have 52 weeks in a year. Looking at 40 years, 45 years of data, somebody said that 1978 week number 1 is a representative week of last 45 years. So if you pick up that week, you are actually representing what has happened in last 40 years. Then second week could be 2009, week number 2. This is real data, right? Somebody has collected this data at the airport or wherever you have meteorological station in India, in Lima. So looking at number of years and all those 252 weeks, we get one file which represents last 40 years of data or 30 years of data or 10 years of data, whatever. And we use that as a reference to understand what's happening inside the building. Right? It is not that you are doing something for 2022 or 2023 or 2024. The building is going to last for next 50, 60, 70 years. And hence you cannot pick up 1 year data. You need to pick up what is a typical things, typical. So when in 2032, when somebody will pick up the data, they are not going to pick up a data of this year, winter. this week, because as I understand, this particular week in Lima this year is little bit more colder than usual thing, right? So this data is not going to get picked up. So you need to have some kind of normalization to a representative year. It's very similar to when you say that there is no, you will not find a person in Lima or in India or in US who would be exactly 6 feet 1 inch, 78 kg, BMI something, but it is a typical person which we assume by looking at huge amount of data, right? So when we are using this outdoor conditions, it is not of 1 year or 2 year or 3 year, it is of typical year which gets derived from large data set. Any questions so far? Now you will wonder that yes, this is all from 1970, sometimes in some countries where historically they are not collecting the data, let's say a very remote place somewhere in Africa or some other South Asian Asian country, they may start with 1990, 1998 onwards. But over a period of time they will build up and they will have a little bit more robust TMY file. Okay. You also will find the versions TMY1, TMY2, TMY3. This is because TMY1 was predominantly between 1960 and 2000. Then we added so the 2010 data set into it, became 2000 TMY2. That is TMY2. Then again 2020, 2020, again 3 becomes TMY3. And that's how the new files will get generated and will have impact of climate change as well. There are processes by which you can say that I don't want to look at this onwards, I just want to look at from 2015 onwards, because I feel that in Lima since 2015 the winter is getting severe and severe. And looking at that, there is something called future climate files. Okay. Future climate files is just a prediction based on very recent climatic trends. You say that I want to have this building future ready, or I want to see what is going to happen if my outdoor temperature averaged out goes up by 0.5 degrees centigrade in Lima because of the climate change, how my energy consumption is going to change. So we don't know what is the data, but we can always predict, and that's called future climate files, right? You also probably will realize that all these data set which we are seeing at the typical meteorological site is at the airport. Most of the data gets collected either at airport or little outside the city. Now, do you have a CBD, the central business district kind of situation in Lima?
We have tsunami. There is
something where you have tall buildings, lot of people. Sorry?
San Isidro?
Financial center?
Yeah, financial center. Basically, lot of tall buildings, lot of traffic. That area will have different kind of climate, microclimate, right? We call it urban heat island. So you also, looking at this data, TMY, you also can do urban morph file. So looking at the data, you are morphing your data to understand if I have too many tall buildings, too many dense places, no trees around, what would be the situation? But it will get derived from TMY as well. Okay. Base is still going to be typical meteorological year, or based on that you derive your future urban morphed file, and that can change from places to places. Okay. Now, what I was showing you earlier is the website. There's a group of people voluntarily managing this website. It's called climate.onebuilding.org. This has all the data which is available in the world in terms of weather files. If you go to region on left hand side here, right, you see Africa region 1, 2, South American region 3. If you look at that, you will get a Peru, and right now you have these many places in Peru with certain kind of code number. These are the stations in Peru. So if you are doing something away from Lima, probably you might need to pick up something. Is it Puno is a city?
Yes.
Yeah. You can pick it up from here as well. Okay. However, Design Builder will not understand this file. You need to change that for a format which Design Builder will understand. If Design Builder doesn't have that in a list, then you can look at it, right? Otherwise, Design Builder itself will give you that list. What I'm saying is that something which is not available within the Design Builder, how to get that. And this is an open source, freely available. Now, you might find you see there are sometimes there are more than one file available for the same station. For example, this ARE or QPOP, right? There are 3 files available here. One is TMY 2004-2018. So it is a 1-year data derived from this data set. Okay. So versus something is available at this data set. And what is available here is probably a combination of both. So if you're looking at some specific year as a timeline, now if you go to any US site, or probably this might be 1960 or 1980 and stuff like that, because they are collecting data from that era, right? Now, that's basically, if you go here, you'll get a zip file. And then these are the sort of files you will get, which are different kind of extensions. I'm not getting too much into the detail, but if someone is more interested in looking at solar photovoltaic as their focus and just want to understand how that works, there is another software called PVSys, not Design Builder, PVSys. If you want to use a weather file for PVSys, probably you will pick it up this one, right? It's the same data, but for different kind of softwares it can be used. Okay? So that's a sort of basic understanding from where we are getting this outdoor data set. We'll be happy to address any question if you have. No. Okay. Any kind of simulation which you do with the guarantee that your building will not perform like that. So if I simulate this room, and if I say that okay, temperature, energy number is going to be X, after 1 year, if I measure how much energy am I using, what is the temperature, and if I compare simulation result with the real data, it will not be close. Guarantee. Why? A number of reasons. Number one, what is my TMY file is telling me and what is happening outside is different. As this time, it is severe cold. The TMY file doesn't really reflect that. Right? Or I assumed that this room is going to be occupied by 22 people, but suddenly this room was used by 60 people for 3 months for some reason. Or this room was not used at all because of the pandemic. Energy consumption will change. Up to the extent that one needs to be very, very close to the reality that if I am starting a session which is going to last for 90 minutes, probably in first 3, 4, 5 minutes, 10 times this door will open and it will open this much or this much and it will close. So amount of heat which is getting rejected or amount of air coming also needs to be modeled. Right? Now, it may not happen that way. I have calculated that my door will open 10 times, but somebody will keep opening the door 20 times. Obviously, energy is going out. So it is guaranteed that it will not match. But you should not worry about it. What you should be worried about is the correctness of your model behavior. And I'll explain you what that is. Why simulation is being used is always to compare scenario, not to arrive at absolute energy numbers which will result into absolute energy numbers. For example, if I have one scenario where I have a full window, if I have another scenario, I have a small window. And by doing that, what is a design decision an architect can take? Or if I have a diffusers here and return air here, versus if I have a diffuser one side and if I have return air one side, this is another scenario. And how much energy consumption will change. So simulation results are always to be compared with a base scenario or one scenario. And based on that, you take design decisions, right? It is, if you really want to operate your building as per simulation, it is altogether another domain. We are not getting there right now. As I understand, there are a large amount of people here connected more with the design of a building and design decisions of the building. And hence, we are just focusing on how to take an appropriate design decision and not operations side. Architects will design, will step out of the room. They are not going to operate the building. Right? So that's what the focus we will have. That was the focus yesterday and today. Now, that means that a geometry of a building is not just enough. I also need to understand how am I going to use this building? How many people will come? When will they come? When will they step out? Same amount of people will come inside or go out. Some kind of activity needs to be mapped and needs to be fed into the model so that model can sort of accurately predict how much energy it is going to use. So we know that this room is going to be used between 9 o'clock in the morning and 6 o'clock or 5 o'clock in the evening. In between there is going to be a lunch time. people will go out. All of that needs to be fed into the computer. So Design Builder provides us an opportunity to something we call it a templates for various various components of the simulation. One of the template is activity template. That means you need to tell computer that how the space is going to be used. Second could be construction template. What is the construction of the building? Third could be lighting template, where how you are going to use light, not necessarily when people inside lights is on. Sometimes you don't need a light, right? Fourth could be equipment template, which is all computers and projectors and stuff like that. When people are going to use computer, also needs to be told, because everything is attached with the energy. So there are multiple templates which you need to define, which will go on top of your geometry, right? These templates needs to be seen separately. So for example, if I have one geometry, this is one kind of geometry, and this is another kind of geometry. I have 5 templates. I can put template A on this, template B on this, right? And then, or basically templates are sort of libraries. Like in AutoCAD you have a window library or furniture library or tree library. Any drawing can take that tree, right? Any drawing can take that furniture. So now what we are getting into, we are developing template or some kind of library for construction and activity. If we can do that in next 1 hour, probably, I mean that's what I'm targeting. 1 hour, a little bit more than that. Okay? So what do you want to start with? Do you want to start with the construction or do you want to start with the activity? Which template do you want to prepare first?
Construction.
Construction? Okay. If you want to do it with me, but I think it's better you understand, and then we'll have about 15-20 minutes for you to make your own instruction template or something like that. We have a tab called construction template here. Now, as I was mentioning, what you see here in a red is our project related templates, or each of this has some kind of information behind it, and all of them come together to make project template. So when I say some here, basically this is a combination of all of these. Okay, you have one template which is project wall, you have another one is a below grade wall, that means basement, yeah. You have a flat roof, and so on and so forth. Each of these are having a certain set of construction. So what I'll do is, and all that comes together to get you this. Okay. Let's try to understand how do you really, what is a project wall and how do you make your own wall. So to do that, if you go at the project wall, I am not sure why my laptop is so slow. You see 3 dots here. The moment you see these 3 dots here, this means there is something behind this as well in terms of large data set. Okay. On your right hand side, you see number of construction, wall construction already defined. Okay. Anyone wants to suggest what should we pick up? Let's pick up, now this is for wall, this is all construction. So let's for a while pick up something called solid brick wall 25 mm uninsulated pre-1990, so very old construction. Okay, if you double click there, that library gets into your file. This is library, but moment you double click it, this guy will be part of your project. Okay, what is that? I mean, by looking at the name, you might not know what somebody is trying to say. The details here is actually giving you what is the conductivity, how many layers does it have, and so on and so forth, and what is the even source of that data. Okay, so this is coming from solid brick wall 25 mm uninsulated pre-1919, DOE, that is Department of Energy number 2 data set, ASHRAE. It is right now part of the wall category. There's one layer, and then you go and sort of start checking out. So define methods is by layer definition has been defined. It has 2 layers. Brick thickness is 0.30. It is not bridged, and I'll explain you what is bridged and what is not bridged. Then you have innermost plaster, which is of 0.01 meter. Outside free convection, no. So basically, this is telling you what is the U value, R value, or conductivity of that whole assembly. Okay. So basically, when you pick up this wall, you are getting 2 things. You are getting brick and you are getting plaster. Okay, it's an assembly which you are getting. It's important that you also, let's say now this is something which is available in Design Builder. Somebody said, no, I did see some fantastic work Martin is doing in his lab, Adobe construction with the rice husk or some kind of husk and stuff like that. It is not part of this library. You want to generate your own. Okay, how to do that? So let's start looking at something which is more specific, which you would like to do, not from the library itself. But before we go there, if you look at edit highlighted data, you can look at what are the walls and layers, and you can also start looking at what are the properties. So I want to see how does this wall look like. I go to image and I say that this is what outer layer, this is what inner layer. This is how it looks. If you go to the surface properties, there is no fixed convection is been defined. If you want, you can define that. Basically, fixed convection means that if the air is moving on top of your surface, it will also account heat transfer through the convection. Right now, conductivity or U value is just calculating conductive heat transfer. It doesn't take any kind of convective heat transfer. If you look at what is the calculated U value, it is 1.7, and what you all see is various kind of conductivity of outer layer, inner layer, no bridging, and so on and so forth. Okay, so how does this particular wall is going to function as far as it is heat transfer is concerned? What this is giving you is details of each layer and their thermophysical properties. Okay. If you are right now, you may not have that functionality, but in future, if you want to do life cycle cost analysis, LCCA, you also can add your cost here and say that, okay, this wall will cost me X. So finally, when you do cost benefit analysis, you say that A wall and X energy consumption, B wall and Y energy consumption. So it will become a little easier if you add a cost here. Okay, we are probably not getting there right now. We are also not getting into condensation analysis, whether it is all, whether you have any kind of chances of having condensation on that kind of wall. We are not getting into mass transfer. Now this is where this is what is there in the library. Okay, available library. I am what happened? Yeah. Basically, my screen was not full fit screen, and hence I was not seeing this. Now this is a locked library data. That means you cannot change this. Design Builder has given you this. You don't have a right to change it. But if you make a duplicate of it, you can change it. Okay? So let's try to do that. So what I'll do, I'll get out of this right now, cancel. I have selected this. I'll still keep, let's work on that. Okay? What I'm going to do, I'll say add new item. If I say plus, it's a wall. Okay? Any question? No. Wall, say PUCP test 1. This is a wall which we are making. This wall has it is going to be defined by layer. Definition of conductivity is going to be defined through layer by layer. So vertical, one layer, second layer, third layer. And we want to say that it is basically made out of 3 layers. Instead of 1, it's 3 layers. Now immediately when you say 3 layers, something else will pop up. Now this is a default. Okay. Mind you, material wall has a material in it, and these are the 3 materials. What you are seeing is outermost layer, which is aerated concrete slab. We need to change this, the thickness of this. We will select what we want to have it. This middle layer and outermost layer. Okay. Now, if I go and need your help, let's say if I go with the 200 mm brick wall, 18 mm cement plaster, and 12 mm cement plaster, would it be okay for Lima context? Or somebody can suggest me the construction which you use? Sorry?
Okay.
Shall we make this wall?
Yes.
Yeah? Okay.
Sorry, what is outdoor and indoor?
Sorry?
Outdoor and indoor, what is?
This is outdoor. This is indoor.
Okay.
This is cement plaster. This is cement plaster.
Is necessary to know for this order?
Yes. I forgot to tell you, although you don't need to bother about it. But in an old time, it was very important to define outermost layer on a left hand side. That was a time when Design Builder was not there in the picture. This is I'm talking about before 2000. In Energy Plus, you need to define something. So as a rule, the left hand side layer was outermost, and right hand side layer was outermost, and left hand side was innermost. If you see it that way. That's how we used to define when we were not having this one. So by default, I draw that. Okay. It can be other way around, because here you can change it upside down later on as well. But let's try to change the aerated concrete slab, which is a wrong material as an outer layer for a wall, to, so you go there, again you have to select which material you want to pick up. So instead of concrete, I will go to something called plaster, right? And then we'll pick up cement plaster, this one with the mortar, and here I will say 0.018. That means 18 millimeter. That's my outermost layer. Right? Now you might have observed that blue, it was black like this. The moment I entered my own data, it has become red. So this is where I have edited this one. Okay? I will go for layer number 2, Again, I need to pick up what I want. I'll go and pick up brick, mud clay brick. I'll say 200 mm, or yeah, let's say 200 mm. And then again, inner one, which is a plaster. I'll pick up a same plaster, but it would be 0.012. Yes? Yep. Okay. Now we need to check whether whatever we have done appropriately or not. We go to image just to verify that whether inner layer is 12 mm or outer layer is 12 mm. Just go to image and check whether whatever you wanted is been constructed accordingly. Okay? Yes? We also need to understand what is a U value or combined conductivity of these three layers. To do that, you go to calculate it, and this is what the U value of the wall which we have made. Okay? Looks good? You go back to the layer, you say, okay, select wall as an external wall, yes. That wall which was there in a library has come to the model now. Okay? Yes?
Could you briefly go back and give us the thickness of your intermittent layer in your wall?
18 to 112.
Okay, yes.
Okay? Now, I want to have same wall but with the insulation. I don't need to redraw it. I can simply say, go back, no, okay, now before I go anywhere, no, sorry, come back. We want to change this as well. I want to make a new wall having the same construction, 18, but I want to have insulation and then 200 brick and 12 inside. Same wall, I am putting external insulation, right? It's a variation of a wall. I again go here, set edit highlighted items. Right? And I can add any layer here, and I'll show you how to layer. But this is not what you should be doing. This is not what you should be doing. What you should be doing, say cancel, say plus. Otherwise this wall will get turned. You want to keep this wall, you want to make a new wall based on this wall, right? You say new item, okay? Again same thing will appear. We don't want to do it, so sorry, I made a mistake. I will go back, this is happening because, yeah. I'll go back here, I'll edit this, instead of this I'll say with insulation, and I should be specific about 50 mm XPS insulation I am adding. Now as you can see here, the earlier file which I selected, the aerated concrete one, which was locked data. This is not locked data, this is model data. This is your own data. This particular model is using the data and this is showing you this is model data, that means you can edit it. Right? And that's what it is, that's why it is allowing us to edit. Okay? what I'm going to do, I will insert a layer straight away. I'll insert a layer, and it will ask me where do I want to insert a layer, whether outside or inside, whether I want to have that layer number 1, 2 or 3. So earlier I was having 1, 2 or 3. I want to make this layer as number 2, right? So I will pick up number 2. And there I will say it's XPS HFC blowing, and I will say it is of 0.05. Okay, you can see that first layer is same original mortar plaster. Layer number 2 became XPS, then we have a brick, and then we have innermost layer. If you look at this image, you know where exactly you have added that layer. Layer was not get added inside or innermost layer or outermost layer, is appropriately inserted. Okay? And then if you see the calculated U value will be probably 0.04. We were in the range of 2, come down to 0.04. Okay? Now this is still your model data. This is all your data for this model. Okay? Any question? Say okay.
Okay.
You're done. You got your external wall construction. Now, do you want to try anything else or this is okay?
Please wait a minute.
Sorry?
A moment.
Okay. The mistake I was making earlier, that based on the current model, current wall, I was trying to make a new wall and I could not do it because I forgot. I should have clicked here. Right? If I click here, create a copy of highlighted item, and then I can edit that. So as you can see here, copy of edited the existing item, and now if I edit it, I can make it same wall, same XPS, but inner, inside. And what I can do is I can reverse construction layer. And if I see that everything else has remained same but insulation has come inside. I'll explain you again. Okay. This is a little tricky because it doesn't tell you what is it doing. So I probably will not go back, but what I suggest is that let me go again here. Okay. Layer is number 2. Okay. I click here. Sorry. sorry. Yeah, if I click here, and then if I go here, reverse construction, again it will get reversed. So only these two will get reversed in order. Are you getting my point? Yes or no?
Yes.
The other option is to delete and
Yeah, other option is to delete the layer, go to other place, add that layer again. Yeah, just click here. Yeah, and just reverse it. No.
No, it is here.
Yeah. No, number 22. Just click here. No, just keep the cursor. That's it. Go out and come back. Yeah, that's it. Reverse it.
Okay.
Confirm. Now you can see the image. Okay.
One of each row like
Only those two got swapped. Outdoor and indoor remain same. Inside and now, if you see calculated, now I'm going to test your knowledge. If you see calculated, U value has remained same, 0.46. So which one will you pick up if you have an air conditioned building? U value of both construction, whether your insulation is inside or insulation is outside, there is no impact on overall thermal heat transfer through the conduction. Will you pick up any construction or will you pick up any one of them?
Insulation inside.
Sorry?
With insulation inside.
If you have air conditioned building, insulation inside. If you have non-air conditioned building, insulation outside. U value will not show you that impact, but energy consumption will show you that impact. Because what will happen is that if you have a layer, if this layer is outside, air condition also will try to cool this part. But here insulation is preventing that. But if you reverse this and if you have naturally ventilated building, then insulation will prevent heat gains. So it also depends upon how are you going to operate your building. Your U value may remain same or your conductivity remains same, but layering will change. Okay? Martin, you don't have energy codes here, right? Energy code? Energy law? Building energy law?
Yes, code. Yes, but it's not mandatory.
Okay, so let's say if I am government and I say that all building must have a U value of 0.4.
Next year will be mandatory.
Okay, so I'll come next year. If somebody says that no, your U value has to be 0.4, not more, not less. You're getting 0.46. What will you do? Probably, one way to do it is that I go here layer and I said instead of 0.5, I go for 0.45. Because I need to, it has to be 0.5, so I need to go 0.55. I'll go here, calculate it. Oh, it's 0.43. I still need to go down. I'll go back here. I say 0.6. In a calculated, this is okay. Just okay. So you are making a wall which is of 0.4, which exactly somebody wants. But the challenge is, if you go and tell people that my insulation is of 60 mm, no company makes insulation of 60 mm. They'll make 25 mm or they'll make 75 mm. So where will you get insulation of 60 mm? So it's a challenge. Somebody is telling you that, so what we do, we say that forget it. I am not bothered about how construction can be made. My energy calculation needs to be done at 0.4 only. I don't really want to understand what layering is. Okay? What you can do? You say, go to layer and you set U value. You don't care about layers. You said, I just want U value of 0.55. And let design builder decide what it wants to do. So we were here, you want me to repeat, right?
No, it was 0.4. No, 0.55.
Okay, 0.4. Okay, let me go there. Sorry. U value 0.4.
In that case, the values of density and heat
Yeah, you can change that.
also.
Yes. So what design builder is doing, that because you have given it a target that you must achieve 0.4, whatever the most insulating layer you have that in a wall, design builder will pick up that and will try to change the thickness of that. Say that confirm update insulation layer 3 from 0.6 to 0.603. And then say, okay, you get a U value which is what you want, 0.4, exactly 0.4. So many times what we do is that in an early design stage, you really don't want to get into cost, you really don't want to get into construction sequence and so on and so forth. They said, let's do, if I change U value from 0.4 to 0.5, what will happen? 0.5 to 0.6, what will happen? And later on you decide whether you want to go for straw, adobe or something else, based on availability of material. Sometimes you said, I want 75 XPS, you go to Owens Corning, said, I'm ordering, he said, our plant is not making it, you need to have a lead time of 3 months. Wait for 3 months before we make it. You don't have time to wait for that. So all that decision, you don't need to take right now when you do energy analysis. With a targeted U value, you can say, okay, this is what it is. Okay. Now, let's try to do this little differently. And if I go to a layer, I am deleting a layer. I select here, I delete this layer. I'm again going back to the same 3 layer with a brick in between. And then with that, I want to achieve U value of 0.4. So let's see, with this your U value would be in range of 2. Yeah? Okay? Now we know that this wall does not have any kind of insulation. We are expecting this wall to deliver 0.4, which is very stringent, and for brick it is very difficult to get you 0.4, but still you want to have it. What you do is that, yeah, you say 0.4, this construction has no insulation layer. Do you want design builder to detect most insulating layer and increase the thickness to comply energy code? You said yes. Then if you say that your brick, which is of 0.2, will become 1.9. Okay. So you got 2 meters of thickness on the wall to get you 0.4 U value. And this will have an impact on carpet ratio, carpet to built up ratio, the amount of wall thicknesses you will have, an amount of carpet ratio, floor to floor, which you sell. Right? So you are not going to do this, right? But what I am showing you is that depending upon what stage of construction you are, You can be lazy. I don't want to make any wall. I'll say that font U value 3, done. And that's what our students do. Tomorrow is a submission. I don't know to figure it out what is the thickness I should be doing. Target U value 0.2, do analysis and figure it out what's the energy numbers. Okay? Any questions so far? No. Now you can do this for all kind of construction. Wall, roof, windows and so on and so forth. Windows we will see a little bit more in detail. But you can make your own wall, you can make your own roof, and you can save that in a library and you can bring this library to somewhere else also. And that I'll show you how to do it. Let's say this model has used these kind of walls. Another project wants to use same kind of wall. You can export library. But before I show you that, probably that will be the end of the morning session. If you have any question or if you want me to make any particular construction, I'll be happy to do that. If not, then I have a question for you. So you decide what you want to do. Yes?
For example, construction with Adobe, that with not a brick, classic brick like this, but an Adobe like just compressed. Is it possible to put this kind of wall of material
Yes?
here?
Yes. That was my question, if you would not ask the question. So for example, that what we did so far is that we picked up the material, available material in the list, and we made a wall. What if I want to make a wall out of my skin? Anything, right? I need to add material as well. That means altogether a new material needs to be added. And it's the same process. So let's try to see that. Let's go to brick wall here. Now here, this brick, burnt clay brick, what I'm doing is I'm making copy of it, because I cannot change this brick wall. It is a locked data, right? So I am copying it, and it may appear somewhere. No, what has happened? It is making somewhere and I can't find it. Here. Okay, let me delete two of them. And I can now edit this one. I'll say wall PUC, sorry, wall material PUCP, and the way Martin does hot plate measurements for his rice husk walls, going to mechanical engineering department, they will give him this kind of values. That value needs to be fed here. Right? What is the new material which you are making and what is the thermal property of that? Also should be known. So let's say this material which he has made has a conductivity of 0.7 or 0.4. Specific heat is, let's say, thermal mass, so it's very high. Density could be, it can remain same. You can also define various surface properties and so on and so forth. You can also define embodied carbon. Are you aware about this word embodied carbon? Embodied energy. You can also define if you know this, whether it has a phase change or not. So you actually, this is the model data. So that means it's your data. So the way we make wall based out of available material, you actually can make material, but for that you need these values, tested values. Okay? And then you can bring this wall, instead of burnt clay brick wall, you can bring that wall here, and you can check what's overall conductivity is 0.2 because we really gave conductivity of 0.4, which has resulted into overall conductivity of 0.2, right? So image, if at all you want to, no, this is the old one. Yeah, right. Because we gave a targeted value. Last two is that sometimes these two are points. Okay, move selected layer to outermost and move selected layer inwards. So let's say by mistake I have placed this layer at number 3. Actually this should be number 1. Okay, so you select that, you say move to the outermost, that has gone outermost, and you got a new assembly. So basically it's a shifting of layers. Yeah, if you have made some mistake. Nothing else. Okay? Any question? Shall we break? It's about 90 minutes. Sorry?
In 10 minutes we have coffee. We have 10 minutes more.
Okay. Any question? Otherwise, let me ask. What is that bridging? Yes?
In my case, when I had this big wall of 1.9 meters, I didn't, I couldn't see the image because when I wanted to, there was an error message and it told me that you can't add this kind of wall. This one?
But if I want in my life make a construction with a 1 meter wall, I can.
Did you give a target U value? No. Did you set a U value? Of 0.5, that is half a meter. It is not allowing you to do that?
If I put one, and I have it.
Okay. And
Just if I want to make more, I think it's not.
make 4 layers of 0.5.
Okay.
So we are seeing something like bridge. something here which is called bridge. Yeah? So what we are assuming right now, that my wall material, that particular brick has certain kind of conductivity, and my wall is made out of that material only. That particular layer is made out of brick only, which is not actually the case. Because you have a brick, you have a mortar, you have brick, you have mortar, you have brick, you have mortar. And the mortar has different kind of heat transfer than the brick. It may happen that this mortar is more conductive than your brick. So one scenario. Second scenario is I have brick layer, I have insulation, I have outer layer here. This insulation is having some kind of fastening to the wall. This is how it is applied. Conductivity of this and conductivity of this is very different. This is probably sheet metal, galvanized iron, or aluminum one, or even steel. There is a thumb rule that if my head of this is, let's say, what I'm saying is that if I have a screw, something like that, head of this is, let's say, 0.5 square centimeter. If I have in elevation, if I'm seeing that one wall which is of 1 meter by 1 meter, to fix this 1 meter by 1 meter, if I use 4 of them, which makes probably about 2 square centimeter of the aluminum area or GI, sheet metal GI area, amount of heat which this guy is trying to protect and amount of heat which these guys will transfer is going to be same. So there is no point in putting insulation if you are putting it through this kind of construction. Are you getting? These are very high conductive material, and they transfer heat. They are like super highways. So when you bridge this side with a super highway, you call it as a bridged. Okay, there are ways and means to avoid this, because you can have a sort of PVC sleeve. First you roll plug, a wooden roll plug, which we what terminology? So if I want to hang anything, yeah, I drill, then I put wood inside, and then I put a screw, right? So that wood is actually a barrier between a screw and a wall. It is not bridging. But if I just have a screw, that screw will do a super highway for heat. So you probably can have certain kind of PVC or plastic material to avoid that kind of bridging. But if at all any kind of bridging is taking place, so you need to take here. That means there is some kind of high conductivity for some part of that. The moment you ask, it will ask for what is the percentage of that, right? So, for example, let's take there. He said percentage bridging. That means there is a one wall, I'm showing you an elevation, which is made out of brick. There's another wall which has a mortar, right? what is the percent of this mortar, which is actually high conductive material than this, needs to be fed there. That is the percentage of bridging. Right? So if you have 1 square meter, and if you have a, so 1 square meter, that means square centimeters, and this is 2, that means whatever number you need to put it here, that's a bridge. And then it will change its calculation. So for an example, it is not bridged if my calculator is 1.2, if I say bridged by 0.004, 005, and if I try to look at it, my conductivity has changed, right? 1.4 to, sorry, 1.2 to 1.5. That means conductivity has gone up because there is a bridging. Did you get my point? Or was that too quick? No. Now, software does allow you to do a lot of things. Not necessarily you should do it. Don't do this. Question? Your computational time will go up. So best is that first you do this, find what is the conductivity, 1.5, take this bridging out, target value 1.5. Right? Otherwise, it will start calculating that 0.004% for entire wall, entire building, and will keep calculating it. It might take, instead of 30 seconds, it might take 5 minutes. Because it has to go in detail of calculation. Okay? Again, computer software gives you a lot of flexibility, not that you need to practice that. Okay? Break. Thank you.
Please put the layer, please.
Sorry?
Put the layer, please. Another layer.
Because this is bridged, and I gave 0.005%, 1.2 became 1.5. Yeah?
What was the rule of thumb?
Rule of?
Rule of thumb for calculation?
Rule of thumb?
Yes.
There is no rule of thumb. You need to actually calculate. Because this could be 5, sorry. How much is it? This can be 1 centimeter. This could be 0.5 centimeter. If you're going for adhesives, the industrial material, it could be 0.02 centimeter. So there is no thumb rule. You need to calculate 1 meter by 1 meter and find out what is the percentage of it.
The material of the percent bridging. I can see the material below the other one. It says material above percent bridging.
This one?
Yes. Above that there is a material.
This one?
Yes.
Yeah, you can select that as well. I mean, what is the mortar material? Let's say if I make the material out of glass, your conductivity will shoot up, right? Okay, so if you don't specify this, if you don't specify this, I need to check what is the material it takes. It's basically about 25% above the base material conductivity. Some algorithm it applies, which I need to check.
10 minutes?
So with the number of various construction, all of them will become your project template for a construction, okay? And that template can be exported or imported. So for example, if you have made one project template where you have your own walls, your own roof systems and so on and so forth, what you can do is you can save that as a template. You say that UCP test 1 and you say the source is Martin, you say okay, sorry. And this also probably you can keep changing the way you want. I mean, next time when you open a new file, you will see this. And directly you put this template, so all the construction which you have made for this project will be available for the next project. Yeah? So basically you have given a template name and that template would be available. Okay? Now, let's say you do see some other templates here, curtain wall, early design stage, so on and so forth. Now, instead of exporting this and importing again, what we can do is that I want to bring some data from some other template here. Okay? We said load data from template. The moment you say that, it will ask that what kind of data you want to get imported. And you don't want everything, right? You don't want HVAC, lighting. You just want a walling construction or construction roof related set. You say that this and this, or you can pick up something else, bring it here. Then in this one, all that other template data pertaining to construction only would be available. Right? So you can sort of, basically what you're doing is you're making your own library project by project, and then you can pick up from which project you want to bring a glazing and which project you want to bring a walls and so on and so forth. Okay? Before I move to another extremely important topic and sort of complex topic, I just want to show you that you also can define the properties for component block here. This one, which is shades, what kind of shades you have. You know, now you know what is component block. Yesterday we made a component block, and if my component block is impacting my building, and if the component block is completely glazed facade, I need to define that here, right? Just let's try to see what all has happened in this project in terms of its geometry. So what all we were working at the building level. Now I'm going to the zone level, and I'm seeing that my wall is copy of something, right? So when I started, it was a different wall. Now it is a different wall. I have changed this wall. Are you getting my point? Shall I repeat?
Yes, please.
Yes, please.
When we started, there wasn't anything like PUCP underscore test 1 template, and nothing was like external wall copy of wall. It was just some project wall. The way we see project roof, project pitch, it was a project wall. Since things have been defined, we are at this level. At that level we changed things. When we go to this level, we see impact of that, which is here. Right? Now, did you get it? What if out of these 4 walls, this wall, which is probably at 90 degree, that means it is on west side wall, east side wall, is of different material. I need to change this and go here and pick up some other material. Best practice is wall medium. So what I'm doing is that earlier I had all 4 walls of same material, but one of them, this is one, this is one, this is one, this one is being changed to material type 2. To do that, you need to go to that level and change it. Only this one has been changed, right? And the moment you change it from blue, it becomes red. Yes? Again, if you see what has happened here, it is still copy. So the second wall, which you see, this one, is still copy of wall. So only one wall got changed, right? Just keep this in mind. I'm repeating. Out of 4 walls, we picked up one wall by selecting a wall and changed its construction. Okay? All other walls have remained same, which was been defined at building level. Okay? Now, I am going back to building level. This copy wall, I am changing it to something else. Let's say cavity wall. Right? I go to wall here. You still see that best practice wall which I selected. But other walls are being changed to cavity wall. I'm repeating. In a previous step, when at the building level, I defined a wall called copy of wall. At that time, I went to this wall, which is at 90 degree, changed it manually from A to B, right? I went back at the building level, copy of wall has been changed to cavity and east-west 1995 part L wall. When I come back, all walls have changed to this new selection, but that wall, which I manually selected and changed it, did not get changed. Okay? So, there are two words which I am introducing here. One is called hard hitting. I did hard hitting here. By force, I say that don't follow what your building level decision is telling you to do. Just follow what I am asking you to do. Right? So, once you do this hard hitting, anything which you change at this level will not be applicable to that place where you did hard hitting. It will never change. Now, even if we go and do this, are you getting what I'm saying? Yes? Okay. Now, even if I go back here, change this to something else, that wall is still going to remain that only. Rest of the walls will get changed. Okay? So one word is hard hitting, second word is parent to child relation. When your parent is asking you to do something, all child will follow that, except one where you did hard hitting. Okay? This is very, very important. What happens is that this is just one zone we are talking about. You have, let's say, 20, 30, 40, 50 zones, and at one zone, you change it manually without realizing that at what level you are. Every time you have to go there and change. Because that guy is not going to then listen to you right from the top. Okay, so when you do hard hitting, make sure that you really are sure about it. Otherwise, every time you have to do this again and again and again, going to that place and changing, that place and changing, that place and changing. It will not understand what happens from the top. And this is true for all components across the design window. Whether it is wall, it is roof, it is lighting, it is activity, it is HVAC, everything. So when you change something, please make sure that you know at what level you are. Many times people say, I did change it but it did not change. I did change it but it did not change. But realize you changed it at this level. You did not change it at this level. Right? So you have a building, you have a block, you have a zone, then you have a wall. And after wall you have layers. That's a hierarchy. Okay, so this parent-child relation and this hard hitting, you always need to keep in mind. Okay?
There is no way to go back.
No way to go back. If you go to that hard hitting place, and let's do this way. So at the block level, I have this brick air with the whatever concrete. Here, I have best practice wall. Okay. Let me try to select something which is easier to select. I am going here. I am going and picking up the first one, which is easy to select. I am going here. I am changing this to this also, which is in harmony with my top one. But still, it is manually done. Now, next time when I go at the building level and change it to the second one, this guy will still remain the first one. So, before, the point is that before you hit, think twice. Okay? Now, you will say that how many, ideally, you need to spend 90% of your time modeling your building, but let me put it a little differently. You need to spend 50% of your time modeling your building, 5% of time simulating your building, because you don't need to do anything, and 45% time analyzing your building. If you keep this ratio, you actually will get what you want. It should not get reversed, that you model for 5% of your time, and it gets simulated for 55% of your time. I mean, you really need to work so that you understand the way computer works and try to minimize its computing power. Otherwise, you will get lost. Every time you ask everything, amount of data which you are putting in, 10 times data will come out, and you will get lost how to analyze it. In this, like 1%, or let's say you are putting 10 inputs into the computer, 100 output comes out. If you put 3 inputs as a junk, 30 junk output comes out. Okay, so it's like a junk in, junk out multiplied by 10 times. So don't do anything which you really, even if you want to learn. See, many kids, and I was sort of also one of those, the moment you get a software, you try to do anything and everything, right? Adobe, you do this, you do morph it, and that's how many people learn software. You will not be able to learn this time. You need to have a strategy, because it will have an implication on how are you going to analyze it. Okay, and that's where this the parent and child object relation is going to be important. Now, this is one zone of one block. You have defined everything what is required in this case. Now you can clone it. There is difference between copying it and pasting it and cloning it. Copy pasting is geometrically you are copying it and pasting it. Cloning, that means you are copying it with all its ingredient. Whatever construction you have put in, whatever layers you have put in, everything is getting picked up, including its DNA per se, and will get cloned. Now, including that hard hitting also will get cloned. Okay, so there is a command here which you see, clone selected objects. You have selected the object, you can clone it, and then you can say, okay, so you got multiple floors, right? So it's a three-story building. You also, I really don't want to go there, but let's say if you want to say, okay, this floor, I want to rotate it. This is a protractor. There is something called OpenGL software visualization functionality in a design builder, which automatically detects which face you are in terms of third dimension. So this protractor, if I click it here, it will turn that way, right? So if you click it here, let's say I'm here, see, it will rotate that way. I don't want to rotate it that way. So what I need to do, either click here, rotate, and I need to be in a horizontal plane. Then I can rotate whichever way you want. Right? So let's say rotate at 90 degree, and then I can move that and you have building something like that. But this means that you have made sure that one floor is absolutely perfectly modeled, and then you are making it again. Or second way of doing it, which is a little more complex way, that you make 3 floors right away, and then try to work at the building level for all that constructions. Wall construction, window construction, by remaining at that level. But then it's always, you need to make sure that what is happening where, you need to have that in your mind map. Okay? I did discuss yesterday about that multi-story building. Which basically has, you don't really need to model anything in between. You can just model top floor, middle floor, and ground floor, and you can keep this as your component block, right? Or outline block, whichever way you find. But there you need to make sure that this floor, this one, and floor below is a adiabatic. Or you can do something like this, which is, I have made a floor here. Let me go back. Just hold on, please change. There is a functionality called, I'm just trying to find where it is. It's basically you select this and all output needs to be multiplied by 5 or 6. So that your energy consumption post-processing, that is after you get the detail in MS Excel, you don't need to recalculate it. It will give you this multiplied by 6 itself. It's called zone multiplier. Okay, if you hit zone multiplier, I think you will be able to find. I was trying to find, but I think the tab which was there earlier has been changed to some other place. So I will not be able to get that. But if I get some 3-4 minutes more, I will be able to figure out. So that's about cloning. That's about doing parent and child object relation, hard hitting, and how you can keep making your templates which you can use for multiple times. Okay? If you don't have any other question, can we go to openings? From construction, can we go to opening? Yeah? Now, the same story here. It's about glazing template. Just hold on. There's few more addition takes place here, and for that it's important that you understand the glazing component or glazing technology a little bit more, because something little bit more complex than simply placing a brick wall and insulation. The nomenclature remains same, that what is glazing template, what is the project external glazing, we will define this. This is all about external one. What is the layout? Now, here, preferred layout is 30% window to wall ratio, where 1.5 meter of preferred height. That gives us something like this. Okay, just to make my life a little easier, I'm deleting some of these. Okay, I want to change this to more percentage. And then when I go to 70, as you can see, with the preferred 1.5 meter height, my area of the glazing has increased to 70%. When I say preferred, that means design builder has kept this height constant, and because it could not adjust the all 70%, it has also increased the top height. That means sill level has remained same, but height of the building window has gone up. Okay, versus if you look at the same 70% in a horizontal strip. Probably, let me try to get you something which we can see a little more carefully. 50%. Yes, this is strip, middle strip as a 50% versus 50% as a preferred height. And you can see the difference between the way design builder adjusts the sill height and the lintel height. This is all automated, right? The moment you say that your window to wall ratio is, it will change on all four sides equally. Same parent to child object relation takes place here. I go to the wall which is on 90%. I go to opening. I said this wall is going to have 100%. I go back to layout. I go to building label. That wall has higher window to wall ratio than rest of the wall, which I have did hard hitting. Now if I go again at the building level and go at the opening and say that my window to wall ratio is 5%, other things will remain same, but that has remained at 100%. Okay? Was I too quick? How to change window to wall ratio? It is automated. The moment you say that 10%, 50%, 30%, you don't need to draw windows. Depending upon area available at the wall, design builder will calculate how much percentage of wall needs to be converted into the glazing, and it will adjust that way. That was one. Second is that multiple ways by which that area gets adjusted. Sometimes you said I want 10% but in a long strip. Sometimes you said I want 10% but in a one place. That what you see in all of these here. Okay? Sometimes you say that I want to have height fixed. So I'm just drawing three scenarios, extreme ones. For example, 30% window to wall ratio, but in a strip, then it will do something like that. 30% window to wall ratio with a preferred height of 1.5 meter or whatever you decide, then it will say that what is a it will remain this as a 1.5 and it will distribute it to this level. Height of the glazing will remain 1.5, but this one remain 30%. So here what happened is that this could be 0.6, but total area could be 30%. Here again total area would be 30%. But height of this will remain 1.5 as a glazing height. Or third one would be you don't say anything, it will adjust the way it wants, whatever 30% comes to, right? So the right hand side options which you see is basically layout of your windows. It is a strip or fixed window, whatever. And as we saw earlier, all of them you can sort of pick it up, make a copy of it, edit it whichever way you want. Same process which we used to do for construction. Okay, but here for the layout. So when we are working in the construction, we are not working at the layout. We are just working at a layer by layer construction. When we are working at the glazing template, we are working at two things. We are working at the layout as well as we are working at the construction. That's a difference, right? Because position of the window also needs to be decided. I'll not go too much into detail here about layout. Yesterday we were trying to put our overhangs as a component block on top of the window. That is one way of doing it. Little easier way or far easier way to do it is just go to shading here. And you say you want a local shading. You say you want 1 meter overhang for a while, just to make it simple. Go to layout and you can see that overhang has come out on the windows. Yeah? But there is a limit to use this. Here it will just consider 1 meter wherever your window is. So if you go somewhere else and you say that my window is now 60%, overhang will go to 60% window. So it will follow wherever the glazing is placed. Yeah? I mean, a little better way of looking at is here, rendered view, right? Now see, where there was a 100% window, the shading has gone to the floor level. Here. Versus wherever there was 60-70%, you had a wall on top or RCC on top, the lintel has remained at that point. Okay, I'm going back and again trying to look at the overhangs. Go to opening, overhangs. You can, let's try to change this overhang. Let's say pick up 1 meter overhang, copy it, rename it, say custom 1 meter or PUCP 1 meter. And now you can do bit of construction of it. What do you want? You want it to be overhang, you want it to be side fins, you want it to be louvers, as you see on the right hand side. Okay? You say that let me keep it overhang, or let me make a let me make it louvers. Or okay, let's keep overhang for a while, just to not to make it very. And I want to make that out of concrete. Whatever, cast concrete. Sorry, I should not have stepped out of this. Now, since I have said overhang, I also can define that how far is my overhang from the lintel. What you were seeing earlier was overhang at that level, right? If you want, you can push the overhang a little up as well. That dimension needs to go here. Okay, and projection also needs to be defined here, and horizontal overlap, which is the bearing in a construction. So right now, this offset 0, that means I am having a window right here. Okay? Offset something else, that means it will get elevated. It will be somewhere here. Okay? And when I say overlap, that means it may start from somewhere here. So in elevation, if I have window here, it may start from here. So this is the overlap which you're talking about. Okay? RCC will always have a bearing on a sides. You also can define that. Okay? Make sense? Yeah, so generally overhang is about 9 inches or so of vertical, whatever, 0.15 to it. Visualize it. As you can see, there is a bit of bearing as well as there is a bit of height between the top of the window and the bottom of the board. Yeah? Go back. If you want to do one more, we can say let's overhang, let's try to make it a louvers. 1.5 or sorry, 0.5 projection, external louvers. Okay, let's see what happens. Sorry. Yeah? You got 5 louvers. You want more? You go back. Opening. Sorry. We need to change this to. Sorry. make out of concrete. Is louvers, number of blades could be 10. Vertical spacing. Now this is what it defines. At the end of projection of overhang, it's called vertical spacing. Right? This is a distance between the bottom of the lintel and top of the inner side of the edge. That's a blade depth. And that's the angle. So what is happening here? The design builder doesn't tell you what is the effective depth. The way projection was getting defined, no, 1 meter or 0.5. Here you have inclined blade depth you can define. You can't say that I don't care whatever is this, I just want a 0.5 here. No, you can't do that. Okay? So there are a number of things which you can define here. If you want to change the angles and so on and so forth. If you just want to try it out, you can. Again, it will have a vertical offset as well as horizontal offsets. Some kind of overlap here. The bearing which you call it. I am not changing it because it's a model data, but you need to, yeah, I can change it, sorry. But anyway, you can go back, visualization, I did not change, hence. And same thing for the side fins. Go back, edit, projections. Instead of louvers, you say, what happened? Overhang and side fins. To visualize it, you got a side fins. Okay? I'm expecting a question here. Any question? Yes.
You can just have overhangs or louvers in one window, or you can have both.
I was expecting that. Or you say that louvers, I have multiple louvers on a vertical face. Horizontal louvers, multiple of them. I can do that. But what about multiple fins? Right? What you see in that building?
Yeah.
You have one building like that. You need to go to component block. Okay? Now, just trying to make things a little bit easier. Component block can be grouped together. So let's say if I'm making one component block, second, third, fourth, fifth, sixth, for one window, all that 6 vertical component block, I can group them, copy 6 of them, copy 6 of them, copy 6 of them. Instead of making 1, 1, 1, 1, 1, 1. That's possible. But beyond this, if you want to do something, component block. Yeah? Component block, you can change it at the angle as well. This is 90 degree.
Yes.
But if you go to Le Corbusier's building, it will be at the angle. You can change that. Right? what I propose. So child, parent, done. This is done, overhand done. Yeah. So basically, construction and opening template, these two together, along with the geometry, you will be able to make a building. Anything which is visible, you'll be able to make a building, including construction and so on and so forth. Next step, I would like to take it towards activity. Okay? But before we go there, should we take 5-7 minute break?
Yes.
I need a little bit. Yeah? Yes. And also, if you want to stay, I prefer that for next about until 12:30, it's about 45 minutes, you practice. Just do whatever you want to do. The last 20-25 minutes I was little quicker than I used to be in the morning or yesterday. So just play around with three things: geometry, construction, opening. Or let me do one thing. Let me spend another 5-7 minutes or maybe 10 minutes looking at the construction of glazing. We just look at the layout of a glazing. We have not dealt with a glass. Let's do that so that we finish opening template. Henna? Sorry, this henna is Hindi word. It's like, okay. What we are doing is looking at a glazing type. Here, we are dealing with now construction of the glazing. When you say glazing type, you go here, you will get single pane, double pane, quarter pane. Let's try to look at a double pane. Okay? This means that you are selecting double blue 6 mm glass on two sides with a 13 mm gap inside. Okay? Let's pick that up, or let's make a copy of it so that we can play around with it, create a copy, open it, sorry, edit it, say PUCP, now same way, the way we used to make wall. What is the material layer? We want to do it with the material or not simple one. How many layers do we have? We actually have 3 layers, which means glass, air, glass. But the air layer, we don't define it as a number of layers. You just define glass layers in terms of numbers. Okay? So the 2, outermost layer, generic blue, innermost layer, generic blue. In between you have 13 mm air gap. If this air gap you want to change it to argon or krypton, oops, 13 mm will remain 13 mm, okay. And what you got is a construction. What is the U value? What is the SHGC? Go to calculate it. Try to find what is the thermal properties of it. U value of 0.46, solar heat gain coefficient of 0.49, and VLT is 0.5. I hope you are in tune with SHGC and VLT terminology. Okay. If you want to put cost, again, otherwise go back to layer. Now, just to make things complicated, what is this flip layer? Okay, sorry. Before I go to flip layer, In India, and I also prefer that you practice that in Lima, never ever have 6 mm, 6 mm, 2 plane in a window. Never. It must be either 5.5 or 6.5 and 6, 5.5 or 6 or 6 or 7 or 7 or 6, whatever it is. Never have a same thickness, because when earthquake takes place, resonance of both material, even if it is matches, you are not going to get destruction in terms of breaking of glass. But if resonance of those two glass is same, both will break. But if you change the thickness, the resonance will change because of the thickness, and one of them will break, second will not break. So there are many countries where thermally it is 6, good enough, go ahead, but seismically we never use two thicknesses together. Okay, so that's number one. Are you aware about glass coatings? So let me go back a little bit more on the physics. So, what you're seeing here is on x-axis is a frequency, and y-axis watts in terms of energy. Any glass which you place is going to bring light, but it also going to bring heat. Okay? The clear glass, this kind, I assume that this is single pane, right? Single glass?
Yes, yeah.
So this glass is something like this. That amount of, a change in the frequency, amount of heat it brings in is very, very high. Whether it is an ultraviolet range, what you need, visible range, or even near infrared. We don't need this in a building. We just need this much. But still, it brings a lot of heat, right? So, what we do is that we coat, or we place a coating on a glass. We place a coating on a glass so that you filter out certain spectrum and you bring in only what you need. Okay? It's like our, very crudely if I have to explain, the mobile phone screen cover which claims that it cuts out the blue light. Are you aware about this? Because people can't sleep looking at the blue light. So there is a new coating has come, you put it on a mobile phone, doesn't give blue light, you can sleep easily. That's what they claim. Something like that. Where it does take out certain frequency of solar radiation and just bring in what we need. What we need to, we need light to see. And whatever frequency is helping us to see, only that is coming in. To do that, they do coating. Silver coating, bronze coating, some other kind of coating. Now, if I do that coating on the single pane glass, because of the environmental pollution, that coating will deteriorate. Many of you would have seen that if you have an old mirror in your house, corner of a mirror will have a different kind of, the coating will go away slowly. Have you seen that kind of mirror? Little damaged mirror? that is primarily because of the coating at the back of the mirror is getting damaged because of the pollution. If we place same kind of glass here, within 3 days, that coating will go away because of the pollution. So that kind of glass always needs to be kept in a cavity. Which means that if I am using a glass which has a coating on top, whether it is inside or outside, I cannot keep it as it is. So what we do is we place that coating on an inner side of the glass. This is outer side, this is inner side, that's the cavity, this is air. That's a glass, and we make frame here, and we protect it so that it does not get exposed to the outside air. It gets exposed to the air or argon, whatever krypton, whatever gas we have filled it in, and its life increases. Now, technically we call this as a layer 1, layer 2, layer 3, layer 4. Okay? This flip layer functionality is going to help there. For example, I am picking up a glass So I have picked up the Saint Gobain SGG Parasol bronze, that means bronze coated glass, and that coating needs to be prevented. If I bring that glass here and say, okay, yeah, sorry. Yeah. So now what I have done is that because I have placed that glass on the outer layer, my coating has gone on the outer side. So this is the outer layer, and this is the outer glass. I have placed that bronze, and that bronze has gone here. I need to bring this bronze inner side, and that when you do that, you need to say flip layer. So this glass will get flipped inside, right? And then you will be able to protect the coating. This is very, very crucial. Otherwise, and this also will change the amount of light, amount of heat which will penetrate. Okay, by flipping that as well. Okay, so this flip layer functionality is basically to make sure that your glass orientation is appropriate. Many times, at least across the world, multiple buildings are been fitted with the coating which is outside, because the person who is fitting there on site can't figure it out where the coating is. So unless the windows are made in a factory, it is impossible for somebody to figure it out whether coating is on outside or inside. Okay. So that's about glazing construction. Yes, one more thing. What you see here is International Glass Database, IGDB, and it says that IGDB is a comprehensive worldwide 5,000 manufactured products version in a design builder. So unlike wall, insulation and roofing, glass are getting tested in 7 or 8 labs across the world. And glass which is tested in those labs, all of that database is available freely on something called IGDB, and all that database is part of the design builder. In XPS insulation, probably 5 manufacturers would be making it. But glass, as you can see here, Saint-Gobain, Wilkinson or Modigard, or basically company by company, you need to have a trade name to identify which material, which glass you are putting in, because all of them will have different kind of characteristics. Okay, hence glass template becomes a little bit more specific towards the trade name. Versus in a construction, you said XPS 75 mm, ABC density. Now whether Owens Corning is making it or Lloyd's is making it, so some other company is making it doesn't make difference. But here, glass is been identified by product itself. Okay? Probably all Asian manufacturing glass in IGDB is tested in my lab. Okay, so this is where I can finish the glazing template, and if you have any question, happy to address. Yes.
Right, I have seen that there are like panels that you can put here. It's called film. The films. You can put films here.
You can put films, yes.
Yes, but the films here, I have seen that they have little thickness, right? So in the Windows gas, how do we eliminate it? Or?
No, it's in microns. So you don't eliminate that. I mean, what you're saying is that you want to account the thickness in a gas, right?
Yes, because there you have to put 2 layers, right? Or not?
Film, you have to put only 1 layer.
Okay. Ah, so you have to put 1 layer and put that there, the film, and
Yeah.
there is like a glass with film,
Yeah.
right?
Yeah.
Ah,
Or you can have single pane glass with the film also. You don't need 2 layers there.
oh, okay.
Like what we generally see in the cars. There's a single glass with a film.
Ah, okay.
I wanted to know how to make a
Pitch roof. Simple. You go. I'm just making. So typically we make something like this, but instead of that, what you do is So here you get sloping walls, pitched roof or dome. Otherwise everything remains same. Yes?
Can you place one window somewhere on the wall that you decide?
Why?
Because that would keep that part more than the other.
You can. You can draw exactly where you want. But let's say in this room, there's only one window, which is that one. Thermally, it is not going to make any difference whether that window is there or in the center. Because amount of heat transfer which is going to take place is the same. And Design Builder as on Energy Plus assumes that this whole air is a homogeneously distributed air. So you can do it. I need to figure it out how to do it, but you don't need to do it. That will make a difference if you are doing a daylighting analysis. That I want more light, I need less light here, more light on that side, and hence I don't want windows here. But for thermal simulation, we don't really care where the placement of the window is.
So one way would be to do different zones?
Different?
Zones.
Zones?
Thermal zones.
Thermal zones, yes. Yes. Yeah, you can do that. I mean, if you really want a window in a center only here, what you can do is that you can make one thermal zone here, doesn't have a window, another thermal zone there, doesn't have window, in between thermal zone has window. So it will get placed right there. And these are virtual partitions. So space wise it's a sort of one, but zone by zone is different. You can. Yes?
Can you help me?
Yeah, if you can speak a little loudly.
Another question that I have is if we
Come in front.
okay.
Yeah, without laptop.
If we want to design a circular window,
You want to design?
if we want to design a circular window, does it affect the report? Does it will affect the report, the final report? Circular window or maybe another form?
Or circular window?
Or single window, maybe that?
Don't.
No?
Yeah. It doesn't matter. As far as the accuracy of the, let's say if I have one wall like that and another wall like that, and both has 30% window to wall ratio, whether I have a window like that or I have a window like this, heat transfer is not going to change.
Just the area.
Sorry?
Just the area.
Area is same, right? This has 30% area of the wall, this has 30% area of the wall. Why do you want to make somebody's life unnecessarily complicated? But having said this, in Design Builder, you can't make this. Purposefully, it's not that software, it's not a software limitation. Purposefully, they don't allow us to do it. I also wanted to touch upon this, but I did not when it comes to a pitch roof and dome. Pitch roof, absolutely okay. But anything which is circular is nightmare for computer. Because for me it's easier to calculate the spot here, but for me it's very difficult to calculate air which is in a circular form like that, because this wall is also affecting this wall and this wall is also affecting this wall. If it is only two plane, not a problem. So if I elaborate this, I have one, I have second, I have third. So I have one, I have second, I have third, and this curve, right? This part is also affecting this part radiatively, because I am seeing it, right? Although it's like right at the sides, but this guy has some kind of, if you project it, there's some kind of viewing factor for a radiating heat transfer to happen, and that's nightmare. Here what happens is that only once it does that. Here multiple times it has to do it. And at the end of that, you don't get anything in terms of accuracy. Right? So even if you want to make dome, if you make a dome with so many segments versus if you make a dome of that, this is much easier. Because this has to calculate only one, and it's a view factor here. Versus this guy has to do multiple times for no reason. Okay? So simplicity makes life easier. Yes?
Can we add windows in the roof?
You can. The cutout in a roof, it will appear somewhere here. Either you can draw a vent or you can make a hole. Just go to roof and then try that out. But then, as I was saying yesterday to the person who asked about courtyard, that you need to define what's there. You need to define that it is an air film for that zone to get complete. Yeah?
Is possible change the louvers for different orientation? Or
Sorry?
north or south? The louvers.
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 Yes. So what you can do is that just select that wall and applies only at that wall. Then go to another wall, apply only overhang there. But that all is hard hitting. Yes.
How can we change the frame, because the frame is
A window frame?
yeah,
Yeah.
window frame.
Yeah? Window frame and divider. Right? You can pick up aluminum frame with a no break, or aluminum frame with a thermal brakes, or painted wood, UPVC wood frames.
Okay.
I mean, you can do all. You can decide the reveal. You know, reveal how, whether this window is flushed or it has a bit of offset. Because if I have a thick wall and if my window is here, this is going to work as a shade. But since I have my window here, it is not going to work as a shade. So you can define this reveal also. Yeah? So this is basically if you want a frame, if you want a divider, vertical, horizontal, so on and so forth. You know, let me show you, since that is open, why windows are a little bit more tricky is that conductivity of a wall is not a big deal, because I know how much heat is getting transferred from here to there. But in a window, amount of heat which gets transferred in the center of the glass is different than amount of heat which is being in the edge of the glass. Because the edge of the glass is next to the window frame. So what happens is that this glass, amount of heat transfer here and amount of heat transfer is different because this is actually giving heat to this, right? And this is giving heat to this. So that's why frame also becomes very important. And what you see here is that this is a normal frame which we get. Now remember thermal bridging, right? Here thermal bridging is taking place. But there are frame available where inner part is just solid PVC. So your aluminum is detached with the inside is detached with the outside. And all that is a low conducting material. This is thermal break. So in the design builder what you see, there are two kind of windows. Here, right? Aluminum window with no break, aluminum window with thermal break. This is much better in terms of reducing heat transfer. Yeah? Shall we break for 10 minutes?
Yes, yes.
And what time is lunch? It's 1.
1.
Yeah, so, yeah, I mean you guys can start playing around. Whatever you want to do. I'm here. And then I want to show, sorry?
1 p.m. you go lunch or maybe before.
No, I think we'll go speaking too. So 10-15 minutes, just play around. And then I will take activity template before we break. So after you come back, you just need to play around as much as you want. Right? Yes? Ibib sir will talk after lunch. Yeah? Part of the what I originally planned, what all we should be doing is an activity template. And I was saying that it's not that building use energy, it is people inside the building who use energy. And hence defining of activity template becomes very important. If you go to activity, you see again activity template which says as a generic office area. So what we will be focusing is more on the commercial office building kind of environment, not residential or not factory. What it shows you, okay, this is what I got. Zone multiplier. So that 6 stories, 7 stories which we are talking about, and I was trying to find a zone multiplier, it's here. So if I say that whatever the space, I have 5 floors like this, instead of making 5 floors, I said 5. So all those zones will be multiplied by 5. Okay? What we are going to see now is more about occupancy, metabolic rate, clothing, and some also set points. We are considering that this building is an air conditioned building. At what set points you want to operate your building. Okay? This all is part of activity template. So let's see one by one. When you say, now you need to tell Design Builder Energy Plus that how many people sit in this office per square meter. So 0.11 person per meter square, we can make it 0.15. Okay? 0.1, see, it's generally we do go other way around, at least in India. That each person has about 2 square meter, no, about choice 24, 1.8 by about 2 square meter per person is the norm which we use. Here it is other way around. People per square meter and not square meter per person. Right? So hence it is, you have to sort of inverse it. Although this can be changed at one point, I will show you where. But for a while, what we are saying is that this is the density of people we have. Office schedule occupancy, if you go here, and I'm just trying to show you what does it mean by copying it, and we'll try to edit it. We'll say PUCP, and it says that how this building is going to be occupied. Now this is a little bit of scripting in terms of computer scripting. There are a number of ways by which you can schedule your building. One of them is a compact schedule. One of the most basic way you can define how your building is going to get operated. What you are saying here is a fraction of occupancy. So right now we have 20 people, 100%. If you have 10 people, 0.5. If you have 5 people, 0.25. So it's the fraction of the occupancy which is getting defined here. Okay? What it's saying is that for weekdays, summer design week, so for some particular week, until 7 o'clock in the morning, there is nobody. That is 0. Until 8 o'clock, that means between 7 and 8, some security staff, maintenance staff comes in, your occupancy is 0.25. Until 9 o'clock, 0.5, and 12 o'clock, 1. So between 9 and 12 o'clock, everybody is in the office. Then people go for lunch. And between 2 and 5, again 100% occupancy. Then again it drops. Right? This is for weekdays and holidays until for weekends until 24 hours 00. So across the day nobody goes there. Same thing in a holiday. So this is how your office is going to be occupied. We call it a compact schedule. There's another way of doing this is a day schedule. Sorry, 7-12 schedule. 7-12 schedule means that you actually can define what's happening where month by month, day by day across the week. Now just imagine that this also has a template. What you're seeing is 8 to 18 is actually a template. So let's see how to change that. I'm just picking up that on Wednesday mornings in January, all Wednesdays in the morning, I want to apply template which says 12:30 to 1:30. Yeah. So entire January on Wednesdays people will come only for 1 hour. That's how this gets defined, right? Only that part people are coming. This another way, you can make your own operation schedule, your own library. So let's try to make something for this one, which we are saying is 8 o'clock. I'm making a copy of it. Editing it, I'm saying that PUCP, and now I'm defining this little bit more in detail. I'm saying that, and if you go here, you can drag this, okay? What you're saying is that, okay, morning about between 8 and 9, 40%, then 100%, then people again will go, but then you can define what you want to do. But then I am also running, this is a professional training program which I also run in the evening for 2 hours. Okay? I also can decide, okay, there are some people who are going to come for maintenance some point in time. So this is how you can define the occupancy. And this comes under custom. You can have single period. Then you don't have hour by hour percentage. You set a flat that okay, between 7 and 3 o'clock. That's it. 100% occupancy. You don't have that gradation which we used to see earlier. This is a little bit easier way of doing it. And constant is also value. Simple value, how many it's a constant profile has value of all days, enter the LU, profile 100 as a fully and 8 as a off. So basically 8% of people are there, you can always make it 5%, 7%, whatever it is. What it will do is that if you are here, sorry, let's say, let me. So at a place where we have defined at 0.15 people per person, looking at this schedule, it will decide how many people are there in the space. Yeah? And this again is a model data. You select it and this you apply, it gets applied here. Now you say that this I want to apply to all of these. Right? Here also it needs to be this. There is a way to select this. Yeah, sorry. And say everywhere I apply this, but on Sundays I apply off. On the vacation time, Saturdays, I apply, off. Sometimes some holidays happens in a, so basically you can, sorry. Oops. So you have a little bit more granularity available with you to decide how people are using this energy, using the space. This is most basic stuff. Okay. Now, we can go. We can say okay. We are applying this. We applied it here. But while people are there, what work they will be doing? They will be doing light office work. That means that metabolic rate is going to be about 0.9 and CO2 generation is going to be X, because HVAC system also need to make sure that you get a fresh air, right? What kind of clothing people are going to have? You can decide summer clothing, you can decide winter clothing. You also can define schedule based on cooling. That means schedule based on clothing. That means you define that each day or each month in the afternoon time or in the evening time we are going to have very formal meetings. People will come with a 3-piece suit, or we are going to have informal meetings. People are going to come with the Bermudas and whatnot. That will define whether they will be comfortable or not. Okay? But right now we are just going generic summer and winter. What is air velocity? Are you going to have a fan inside, ceiling fans or pedestal fans? I'm not getting into details here, but you can decide that as well. What is very important to look at is computers. So when you say computer, it will immediately ask how many computers are you going to have and what kind of computer. So if you are going to have laptops, you said about 11 watts per meter square. If you have a desktops, it will go to 28, 29, whatever it is. If you are going to do 2 screens, more power required. Yeah? But you need to also state that how these computers are going to be used. So in this one, actually I need to go and say that if I pick up that PUCP occupancy file here, the one which we made, which is for occupancy, this one, that means what I'm saying is that whenever people are inside, they will use computer. See, these are 2 separate things. Earlier I defined how people are going to occupy. Now I need to define how people are going to use computer. It may happen that this is a classroom. For half of the time I will not allow people to use computer. Or if it is an office, whenever people are there, they will use computer. If that's the case, you have to duplicate what you have picked up for, what you have designed it for this one. So this means that I have X amount of computers, and whenever people are there, they will use computer, because computer schedule also needs to be defined. Here it is defined as with the people. Otherwise you can have your own schedule also. Right? So let's say if there is a space which is primarily for sales office people. Morning times they are not going to use computer. They'll be on phone, they'll be calling people or whatever. Then you need to define with that. What is the radiant fraction of which 0.2 is amount of heat your computer will generate out of 11 watt per meter square. Right? Otherwise, how will it calculate how much of amount of heat it has to reject out of the space? So efficiency of your computer generally is defined as 0.2 fraction. So 11 watts is your power. Out of that 11 watts, 20% of that is getting generated as a heat. Right? So that's why that's what the occupancy schedule with the computers. Then you have office equipment. Office equipment also needs to be scheduled. Now if you look at this schedule, you can say no, we are not going to use fax. Fax is gone. But let's say coffee machines, routers, all those office Xerox machines or photocopying machines, we're not going to use it in the morning time. Then you need to schedule it that. If you're going to use it along with the people, you don't know when people are going to use it. That means you need to apply same schedule here. If you don't have any restriction. So whatever is happening inside also needs to be defined and scheduled for that. That's what the activity template is. Okay, very, very important. I mean, if you change this here, just imagine you have more holidays. Suddenly your energy consumption will drop. Because anyway you have 104 days as a weekends out of 365 days. So 30% anyways, or less than 30% anyways gone. So it depends, even 1 week of holiday will have a spike in a consumption. Do you have anything other than that? Define that. If you have a catering equipment inside, define that. If you have process load, now what is process load? Let's say I'm having some kind of machine in my office. For example, blood testing machine, or I have some kind of what do you call microscopes which use electricity, or I have anything which is required for your occupation, right? Let's say if I have a photography place and if I have those bulbs, probes, all of that is a process that also needs to be accounted separately because they don't have space anywhere. Okay, and they are getting operated with a schedule. Sometimes you also can define like UPS. You said that UPS is going to get operated 24/7, 365 days. Because they will charge, they will discharge, or data center, a small server room, you have to have different kind of occupancy or operation schedule for that. So activity template it actually defines how people are going to occupy, and along with that how other electrical appliances is going to be used. Okay? Last on this is these two. How do you want to operate your space in terms of temperatures? So what is your heating set point? Heating setback. What is cooling set point? Cooling setback. So let's say I want to operate this space at 24-degree cooling and 22-degree heating. That means anything which go beyond 22, my heating will start. Anything which will go above 24, my cooling will start. So I will remain in a range of 2 degree of between 22 and 24. Right? So this is how you define your set points. What is setback? Are you aware about setback? No. Okay. Setback is something where office is not going to get occupied, but still you want air conditioning to operate. Why? Let's say I have 2 degree of band, my heating set point, is 22, my cooling set point is 24, and I am operating my building within this band. Okay? Now, setback is, let's say, 28 degree for cooling, and setback is, let's say, 18 degree or whatever it is, 12 for heating. When I leave office, let's say I'm operating my temperature somewhere here, okay, in this range. In summertime, when I shut off my office, when I go home, the temperature will rise. Okay? Next day, when I come back, it needs to be brought here. But it needs to be brought not like this, but it needs to be brought like that. So I really need to, first 30 minutes, I really need to pump in a lot of cooling, and my energy consumption, my capacity needs to be very high. It's going to impact my energy consumption. So what I'm saying, don't let it go up beyond 28. So whenever I am out of the office, I am going, the moment it hits 28, start air conditioner. Operate until I come back, and then I'll be able to meet it easily. This is very similar to what happens in a car or bike on a red light junction. That if you have less than 15 seconds, you don't shut off your air conditioner, your engine, right? You keep your engine on, because cranking on and off will use more fuel than just keeping it on. Very similar to that. Same way, if my temperature is going to drop drastically, suddenly I will need to put it up. So I'll say, if it drops beyond 12, just start a heating. So next day I have easy time to bring it to that level. That is what the setback is. And you can define that. This is all primarily HVAC related stuff, but it's important at this level where you actually understand what's happening. Looks okay? So with this, I think most of the thing which I wanted to convey ends. And if we start something more, we will require really lot of time. Generally we take, whatever I have delivered, generally we take probably 2 full days going step by step by step. But looking at the first opportunity, we said let's compress it in whatever 7-8 hours we have. So after we come back from lunch, for about 1 hour, 1.5 hour, 2 hours, you model, try to make your own templates, try to simulate and see what happens. For example, what you can do, you make a building, north-south orientation, change orientation, see what happens. You have 30% WWR, make it to 40%, make it to 90%, see what happens. Add shading on top of this. See what happens. Put your building in Lima, take it to San Francisco, take it to Jaipur or Tehran. And see what happens. And look at those graph which pertains with the solar gains, conductive heat gains, and so on and so forth. Because in all these scenarios, your activity is going to remain same. So computer power remains same. Your equipment will remain same because you are not changing. It does not have anything to do with the outside temperature, right? But you also can change. What's happening? What you can also change, that set point 24, make it to 27, and see what happens. Right? The heating set points, instead of 22, take it to 18, and see what happens. So these 4 or 5 basic exercises, if you do, you will start getting what's happening, where to look, and so on and so forth. Let me tell you, after whatever years of work, when somebody comes with any kind of results, by instinct you should be able to know, does it make sense or it doesn't make sense. Even looking at a model, even looking at any of the data, simply you need to figure out, I think it doesn't make sense. Just go and check your model. At least that level of maturity you should get probably next 2 years, 3 years or so. Otherwise, what will happen? You will get bogged down every time looking at what's happening in your model, and it's like endless process. Okay. So with that, I'll stop. And happy to take comments.
President, we have talked maybe the best way to continue is that everyone go to lunch.
Yeah.
Lunch, and we close the
Okay.
class with key, so we can let the computer here.
Okay.
And then around 2 or 2.5,
yeah,
we come back.
Okay.
Maybe not.
So who feels that they have got what they wanted to get? Who feel confident? No one?
Well, confident in being motivated.
You motivate or demotivate?
Confident in being motivated.
Good. Otherwise, it can go other way around also. Hey, this is too much. I did not expect it. Let me step out.
Personally, I don't know what everybody thinks. I think it's too much, but going in a bad way. I think if you want to make it work, because it's so precise, it's also good.
No, so that's what I'm saying. That I think there are two things which I would say. Until you know the building physics, don't work on this. Simply don't work on, because this guy can take you for a ride. Let me tell you, it will not make sense if you don't know the physics or how building operates. So that's number one. Number two, don't try to be too precise. Take step by step, right? Let me look at Google map, then I'll go a little down, then I'll go a little down, then I'll go a little down. So start at the annual energy consumption. Does it change? Then yes, it does change. Okay, does it change in the winter? Does it change in the summer? It does change. Does it change in the day? Does it change in the night? It does change. Then you say, what is happening at the wall? What is happening in the window? If you start right from the window, gone. Right?
Well, thank you. Nos vemos a las 2:30 más o menos. Máximo. Entre 2 y 2:30 van a ver. Justamente, como no estamos seguros del salón, creo que vamos casi al frente a Sofía.
Talk about Ellipsa. There are a lot of web-based resources available. 90% of the energy simulation world just relies on what is available on the net and learns. Very, very few universities have a formal program where teach Design Bureau Energy Plus. Even if they teach simple, many principles, not really how to do it kind of stuff. Okay, so I'll talk about these two things. Let me first talk about Ellipsa. It's called make me open it right away. It's called International Building Performance Simulation Association, right? This is a group of people who since years working in a building simulation area. They have academicians as well as there are professionals, also students. It has number of chapters across the world, and you can see here there is a chapter in Chile, but probably very soon we should have a chapter in Peru, right? We are, with Argus and Martin, we are trying to form a group in Peru so that there could be more and more interaction, more number of training programs, more number of lectures, and other thing can happen. Typically, this organization is governed by a group of people, and this organization is registered in Canada. So it's a legal formal organization. There are two categories. I would say 99.95% members are free members. Only 63 members are paid members. Then you need to pay to carry out certain kind of work. But we have probably about 7,000, 6,000 members across the board. Not necessarily you need to pay, and you can get an access to all what you say. Okay, so I'll stop here, and I'll request Argus to say something more about IBIPSA and what you are planning here in Peru, and then I'll talk about few other resources which you can look at it on the internet for simulations. Right, Argus?
Well, first of all, I've been involved with IBIPSA the past couple of years, and I sit in their conference committee. And I've seen their processes throughout the past few years. IBIPSA, you can probably see it as a body that transfers freely and widely knowledge. And if you are interested in the performance simulation of buildings through simulations, then I would personally very highly recommend it that you get involved. You might think that you are in a preliminary level, it might be your first interaction with the software, but this is a really big world, and you can only gain from this, from forming a chapter, from participating, and from engaging with. This is a very international community. It's not the only one that exists, but in our field, it's the strongest. And one of the best things that they do is they put up this international conferences every other year. It's a biannual conference. It happens in a different part of the world every time. You can find a lot of information if you were to explore all this lists here. But it is the biggest, most important, most diverse conference in our field. One of the biggest I know, the biggest I've ever been. There's up to 1,000 people attending every time. There's 600 at least presentations that have been peer reviewed for acceptance. So it's not something that anybody can present. You'll have to send your abstract, get accepted, send your paper, get review, get comments, acceptance, rejection, etc. And this is all this all happens through IBIPSA, through people, academics, practitioners that they put their effort and time in there for completely as volunteers. So the conference is a major part of IBIPSA in terms of how they share their knowledge and how they engage with the community. They also have, I don't know, Rajan, could you go to YouTube IBIPSA? Because they also have a series of seminars and workshops that happen monthly, weekly. There's a lot of material. It's all freely available. There's experts all around the world that contribute to this knowledge sharing. I think overall I've been involved, so we organize, there's local chapters as well, as Rajan explained, and the one in England is fairly active, and I was part of the chair committee that we organized the conference in England a few years ago. It was the first online conference that IBIPSA was ever involved in. There was a lot of challenges. But now as we go forward, we're really trying to push towards a hybrid format in conferences, so both in person and online participation, so we can really open it up to most of the world, because you can understand if it's in person, not everybody can attend, or if it's online, then some people, they really, as you understand, in-person interaction is very, very important as well.
Yeah, so a little bit about IBIPSA University. There are around 40 videos available, and each video is talking about one kind of topic. For example, climate files, for example, future of simulations, for example, daylighting, for example, computational fluid dynamics. And they are probably 1 hour, anything between 30 minutes to 1 hour, 1.5 hour, 2 hour, whatever it is. And long list. Also, there are certain which will help you to understand sorry, that's about it, but yeah. There are quite a few where we also invite students to talk about their competition projects. So during this conference, student simulation design conference takes place, and 3 top winners, I invite them and they actually present their work, gets recorded, and it's all here. You will hear my voice in all of these, at the beginning and the end, but this is completely voluntary activity, and this is available wherever you are. So this is about one. Second is what I was showing you here. These are all conferences has happened in the past since 89. From Vancouver to Rome. The latest one happened in Netherlands, and probably next 2-3 months you will have information about it. Now, if you go here, 2019, it will show you kind of topics they dealt with: development, building physics, education, energy storage, optimization, whatever. And then if you go, what are the papers available? And all of them are freely available. Right? So the moment you click it, you get to that paper and you can read it. Okay? So whenever you want to know a little bit more about a particular topic, this is a little bit more academic way of looking at what people have worked on. There are some students here, I don't know whether they're undergrad, postgrad, but if you are looking for some foreign university education, this is also best place to get in touch with the professors, work with them. It is likely that you will get a scholarship to study in those universities, right? So it's one second thing about it. So that's about EBIPSA. We are trying to influence Martin to develop a chapter here. The moment you have a chapter, things will get a little bit more formalized. Not necessarily that you need to meet every week, but probably once a month, 4 times in a year. You can have lectures, you can have a common exchanges, and so on and so forth. So we encourage you to have a EBIPSA chapter here. What you need is just about 10, 15, 20 people, like-minded, commit, okay, we will work towards this, that's it.
It might sound a little bit more academic, but it really isn't. This is cutting-edge research you can find on the website. Am I right, Rajan, that Drew is now the president, and the head of IBIPSA is not even academic right now, right? He's a very highly respected practitioner. Rajan, friend, I would call probably. So this is really, more than anything, I guess, if you have passion for the field, I would highly recommend you try the formation of the chapter. There are chapters throughout the world that are completely inactive. You know, they made the first step, but then nothing much more happened. But there are chapters that are very, very, very active, and you know, everything in between. I would suggest it very, very strongly. Try it. This project is formed through Rajat meeting Paul in one of the conferences I've heard, and you know, so much work has come out of this. So it really is a spark that can bring so much more.
Okay, so that's about EBIPSA. It's not a sales pitch. We are not trying to sell anything here, but we highly encourage that you guys come together and try to do something. Now, a few other websites. One is called EBIPSA sorry. Sorry, sir. It's called Big Ladder. Now, Big Ladder is a company, but almost all resources which is available here, again, it's free. Okay, they have Energy Plus, energy management module, controls and sensors, and how do you really model it, these things. They ran a web seminar. Just click it here, you will get that web series. If you take practitioners web series 19 October, again you will be able to reach. Some of them might be on a paid basis, but most of them are freely available, right? So this is one, but one of the most important part of the Big Ladder is again on a Big Ladder, Energy Plus web-based documentation. If you look at one of them, it's called engineering reference. What it is going to show you is, for example, those who are interested in knowing why it is happening, what is happening, right? Most of the software you will come across in the world are black box. You put something in, you get something out. Design Builder Energy Plus is not like that. It actually will tell you that because of this particular algorithm is been used to calculate moisture transfer in this case, right? So everything is transparent. If you really want to know why am I not getting too much of moisture in the room, you can check it out here. That because of this equation, and because it is a function of something else. So this is also one way to increase your understanding about building physics, building operation, occupancy, and so on and so forth. And everything this is available on website. I highly recommend that whenever you, so this is one, I would say, input-output references. Also, what you should put as an input general rules. Somebody is trying to understand natural ventilation. Yes, when you want to do natural ventilation, but you need to make sure that your heating and cooling is off. Otherwise, what will happen? Windows are open, heating and cooling will take place, you will still get energy, and you will not get a benefit of natural ventilation. So, many things which are required, if you read this, if you really read this, I bet you don't need people like me. I really do. You really don't require, you don't even need to go to university if you really read this. It is that exhaustive. Okay? So that's about it. Design Builder itself, runs number of videos, 5 minutes, 10 minutes, 20 minutes, 1 hour, where you will be able to understand what are the capabilities, how to model it, how to simulate it, and so on and so forth. Okay, again, YouTube of Design Builder will help you to get there. Now, what I'm saying is all about when you want to learn what is available. So it is sort of one-way traffic, right? You go and hit the website, you search it, you learn it. It's sort of one-way website, one-way traffic. What about two-way traffic? Where you say, since 3 days, I'm trying to figure it out. This is what is happening. What is happening? I can't figure it out. Can somebody help me out? It's not available anywhere in the website. Yes, there are forums. Again, voluntary forums. You just post your query. Somebody in the world will help you out. Okay, but that is a double-sided sword. If you don't ask appropriate question, not only somebody will nobody will answer, but somebody may abuse you also. I mean, I have seen couple of posts that some novice, very junior person asked very basic stuff, and somebody got angry. Then what are you asking? Whatever. So, to do that, I also show you sorry. onebuilding.org, and if you go here, you go to build sim, okay, building simulation. Now this is sort of email group. That means you become a subscriber to that email. If you want to receive email every day, you will receive. What I do is I receive email once a week. So last 5-6 days, all questions comes together on Saturday morning. Somebody has asked question, I will check it out on Saturday morning and say, I'm in a good mood, let me reply this particular guy. I'll reply it. So you can subscribe to this email group and you will get whoever is talking. Somebody has asked question, somebody is answering it. So somebody says, oh, this is not the way to do it, this is the way to do it. So even you will be able to read that discussion. If you want to post any question, I would suggest that there is a repository of, So this is, I'm just showing you what has happened in the past, right? Somebody said ASHRAE standards appear to be written in a building which eliminates cooling system, but I think lower line could be used when you are trying to eliminate heating system. And then number of people have answered that. Now this is historical data, how people have answered. Let's say if I go to, let's say this is one whole ASHRAE variable air volume HVAC fan curve, and somebody has asked that question and people are trying to answer that. Okay? You go the previous message or next message and so on and so forth. Okay? So far, not a single person in my university has come to me and say that I have not found the answer to my question through this. That means since 20 years, people are asking questions and people are answering those questions. That means if you have any question, it must have been answered somewhere. If you ask, if people are in good mood, they will point it out. September 2020, somebody has answered this, refer it. But please make sure that before you post anything, you know whether it has been answered or not. There is a guy sitting in Chicago, he actually monitors. When you send an email, it doesn't go to everybody. At the end of the day, this guy will look at it. It seems that this is the correct answer. Language is okay. He will say, go ahead. And that particular email gets shot to everybody. So there is a moderator who moderates both ways. Okay? But I have found this as one of the best resources. Apart from this, design builder help file, user manual, anyway it's there. Only one sort of suggestion, that if you are connected with the internet and if you ask for help, design builder will go to their server and will try to find an answer. But if you are not connected to the net, then it will not go to server. Now, sometimes what happens, like somebody said, oh, I'm in a remote place, or I'm going to travel and I want to understand. You can download the entire user file on your desktop. It will take some amount of volume, hard disk space, but you can still download that and then keep referring that. Okay, so that's enough. But by default, everything is on the web so that your hard drive doesn't get clogged. Okay? So these are the things available. I again request you to look at it. If you still want to do a very, very formal education of simulation, there are 2 days, 3 days courses taking place, exorbitantly expensive. Probably 3 days will cost you around $1,500 US. I won't advise you to do it at the beginning. When you are 2-year, 3-year kind of maturity level, then if you spend that money, you will be able to extract out a lot of information. But at the beginning, I suggest that you just rely on what is available on the net. So with that, I thank you everyone for spending your Friday evening and Saturday trying to figure it out some new stuff on computer. And let me write down my email ID. If you need any help, this is RAJAN. Okay, and that's a website where a lot of our work is being posted. You can keep checking that. Thank you very much.
Thank you.
Welcome.
Creo que nos da una tarea. ¿Ah? Ah, una foto. Maybe a photo.
Everyone in the front, everyone in the front.
¿Qué?